The moment astronomers have been waiting for has finally arrived. October the 29th, 2025 marked the day when 3I Atlas reached Perihelion, its closest approach to our Sun. For months, observatories around the world had their instruments trained on this mysterious interstellar visitor, expecting to witness a predictable dance of physics as it rounded our star. What they discovered instead has left the scientific community grappling with data that defies conventional explanation. When 3I Atlas first appeared in our solar system, it seemed to follow the familiar script of interstellar objects. Like its predecessors Oumuamua and Borisov, this cosmic wanderer from beyond our stellar neighbourhood was expected to behave according to well-established laws of celestial mechanics. Comets brighten as they approach the Sun, their surfaces warming and releasing gases in chaotic bursts. Asteroids maintain steady trajectories, their paths carved by gravity alone. The mathematics are clean, the predictions reliable. But as 3I Atlas swept through its perihelion passage, something unprecedented began to unfold. Multiple observatories across 3 continents recorded light patterns that shouldn't exist. Instead of the smooth, predictable brightness curve that decades of comet observation had taught us to expect, 3I Atlas exhibited something far more complex. The object pulsed with an almost rhythmic precision, its luminosity spiking and dimming in intervals that seemed too regular to be natural. The first anomaly appeared in the photometric data streaming from telescopes in Chile, Spain, and Hawaii. Rather than a single peak of brightness at closest solar approach, instruments detected 3 distinct spikes separated by nearly identical time intervals. Each pulse registered with mechanical precision, occurring every 58 minutes with an accuracy that would make a Swiss timekeeper proud. When solar interference was ruled out and instrument calibration verified, the implications became impossible to ignore. This wasn't random scattering of sunlight off an irregular surface. This was modulated reflection, as if something within or on 3I Atlas was controlling how it interacted with our star's radiation. The brightness surges weren't gradual increases typical of cometary activity, but sharp, instantaneous jumps that suggested a surface capable of rapid reconfiguration. The timing coincidences grew more disturbing as additional data arrived. NASA's Parker Solar Probe, positioned millions of kilometers from Earth, recorded identical pulse intervals. The European Space Agency's solar orbiter confirmed the same pattern from yet another vantage point. 3 independent platforms separated by vast distances and viewing angles all witnessed the same rhythmic display. The probability of instrumental error across such a distributed network approached 0. When researchers examined the spectral composition of these light pulses, they encountered another puzzle. The reflected, radiation wasn't uniformly distributed across wavelengths as natural materials typically produce. Instead, specific frequencies dominated at precise moments, creating signatures that resembled engineered rather than organic processes. Narrow-band emissions appeared at regular intervals, their intensity varying in lockstep with the brightness modulations. The thermal data proved equally perplexing. Objects passing close to the Sun follow predictable heating and cooling cycles based on their composition and structure. Rocky bodies absorb radiation gradually and release it slowly. Icy comets sublimate in chaotic bursts as volatile materials vaporize. But 3I Atlas exhibited temperature variations that seemed to defy these fundamental principles. Rather than the steady thermal curve expected from solar heating, infrared sensors detected oscillating patterns that mirrored the optical anomalies. The object appeared to be actively managing its heat distribution, with some regions cooling while others warmed in ways that suggested internal regulation rather than passive response to solar radiation. Temperature spikes occurred not on the sun-facing hemisphere where heating should be maximum, but in offset regions that aligned with other mysterious phenomena. The plasma environment around 3I Atlas revealed additional irregularities. As the object moved through the charged particle streams flowing from our Sun, it created disturbances that didn't match those produced by typical comets or asteroids. Instead of chaotic turbulence, the plasma interactions showed structured patterns that repeated with the same timing as the optical and thermal cycles. 3 primary outflow jets were observed during the perihelion passage, each emerging from nearly identical positions relative to the object's rotation axis. This geometric precision stood in stark contrast to the random, erratic jets typically seen in comets, where volatile materials burst from weak points in the surface without regard for symmetry or spacing. The jets from 3I Atlas maintained their positions and orientations with mechanical consistency, as if guided by some internal framework. Most remarkably, these jets didn't destabilize the object's rotation as natural outgassing should. Instead of creating the tumbling motion expected when asymmetric forces act on a spinning body, 3I Atlas maintained perfect rotational stability throughout its solar encounter. Its angular momentum remained constant despite the apparent thrust from escaping materials, suggesting a level of dynamic balance that seemed almost intentional. The spectroscopic analysis of these jets revealed another anomaly that has left planetary scientists searching for explanations. Each outflow stream exhibited distinct chemical signatures, with one dominated by carbon monoxide, another by molecular oxygen, and the third showing concentrations of metallic vapors that shouldn't exist at the temperatures and pressures involved. The presence of vaporized nickel in particular raised eyebrows, as this element requires extreme heating to sublimate under normal circumstances. When trajectory calculations were updated to account for the observed outgassing, the results showed something that violated basic assumptions about interstellar objects. Rather than following a purely gravitational path influenced only by solar attraction and random jet forces, 3I Atlas appeared to be making subtle course corrections. The velocity changes weren't chaotic or destabilizing, but precisely directed along vectors that enhanced rather than disrupted its orbital stability. The timing discrepancies that emerged during Perihelion added another layer of mystery to an already complex picture. Multiple observatories with synchronized atomic clocks recorded the moment of closest solar approach at different times, with variations that couldn't be explained by light travel delays or instrumental lag. The timestamps diverged by minutes rather than milliseconds, as if the event itself existed in slightly different temporal frameworks, depending on who was observing. These chronological anomalies coincided exactly with the brightness pulses recorded earlier, suggesting a connection between the object's luminous behavior and the apparent distortion of time measurements. Some theoretical physicists proposed that localized spacetime effects might be responsible, though the mass required for such gravitational lensing would be far beyond what 3I Atlas could possess based on its observed size and behavior. The post-Perihelion data has only deepened the enigma. Rather than fading predictably as it moves away from the Sun, 3I Atlas has maintained anomalous brightness levels while exhibiting continued signs of controlled behavior. Its outbound trajectory shows subtle deviations from purely gravitational motion, with course adjustments that appear calculated rather than random. Perhaps most intriguingly, the object seems to be aligning itself with the ecliptic plane, the orbital region where Earth and the other planets reside. This gradual reorientation requires continuous adjustment over time, the kind of precision navigation that natural objects simply don't perform. The implications of such behavior extend far beyond conventional astronomy, challenging fundamental assumptions about what constitutes natural versus artificial phenomena in space. As observatories continue to track 3I Atlas on its outbound journey, the scientific community finds itself divided between those seeking natural explanations for the anomalies and others who quietly acknowledge that the data may be pointing towards something unprecedented. The object's behavior has been too precise, too coordinated and too purposeful to easily dismiss as coincidental physical processes. The story of 3I Atlas and its remarkable Perihelion passage represents more than just another unusual space rock. It may mark a turning point in our understanding of what travels between the stars and how we recognize truly extraordinary phenomena when they visit our cosmic neighborhood. The data continues to accumulate, each measurement adding new pieces to a puzzle that grows more intriguing with every observation. What happened during those crucial hours when 3I Atlas swept past our Sun may reshape our perspective on interstellar visitors and force us to consider possibilities that extend far beyond conventional astrophysics. The evidence is mounting that something remarkable occurred during that Perihelion passage, something that demands explanation beyond the comfortable boundaries of natural phenomena. The electromagnetic signatures detected during 3I Atlas's solar encounter have proven equally baffling to researchers attempting to construct coherent models of the object's behavior. Traditional comets and asteroids produce predictable magnetic field interactions as they move through the solar wind, creating disturbances that dissipate randomly through the surrounding plasma environment. The readings from 3i Atlas told a completely different story. Parker Solar Probe's magnetometer instruments recorded field variations that seemed to pulse in perfect synchronization with the optical anomalies observed from Earth-based telescopes. These weren't the chaotic magnetic turbulence expected from a tumbling rock venting gases into space. Instead, the field perturbations showed remarkable coherence, rising and falling with clockwork precision every 58 minutes throughout the Perihelion passage. The magnetic signatures exhibited characteristics that physicists typically associate with controlled systems rather than natural phenomena. Each pulse began with a sharp spike in field strength, followed by a gradual decay that matched mathematical curves describing engineered electromagnetic dampening. The precision of these patterns exceeded anything seen in previous observations of comets, asteroids, or other solar system bodies. When researchers attempted to model these magnetic behaviors using standard plasma physics equations, they encountered fundamental problems. The field geometries required to produce such coherent patterns would necessitate internal structure far more organized than the loose rubble piles that comprise most small solar system objects. The mathematics pointed towards something with defined electromagnetic properties, possibly involving conducting materials arranged in specific configurations. The spectroscopic evidence continued to accumulate in ways that challenged conventional interpretation. Beyond the metallic vapors detected in the outflow jets, sensitive instruments identified trace emissions at wavelengths that corresponded to industrial compounds rarely if ever seen in natural space environments. These included complex carbon-metal combinations that typically form only under controlled laboratory conditions or high-temperature manufacturing processes. The nickel emissions proved particularly troubling for researchers attempting to maintain natural explanations. While nickel exists throughout the solar system in various forms, the specific wavelengths and intensities detected from 3i Atlas matched those produced when pure nickel undergoes rapid heating and cooling cycles under precise temperature control. Natural sublimation processes don't typically produce such clean spectral signatures, especially not ones that repeat with mechanical regularity. Additional chemical analysis revealed isotopic ratios that didn't align with expectations for interstellar material. The proportions of different atomic variants suggested refinement processes that concentrate specific isotopes while depleting others, a phenomenon common in technological applications but extremely rare in cosmic environments. These ratios remained constant across multiple observations, indicating uniform composition rather than the heterogeneous mix typical of natural aggregations. The thermal management displayed by 3i Atlas during its solar passage defied conventional understanding of heat transfer in space. Objects approaching the Sun typically develop temperature gradients based on their rotation, composition, and structural properties. The Sun-facing hemisphere heats up while the shadowed regions remain cold, creating thermal stresses that often lead to fragmentation or irregular outgassing. Instead of this expected pattern, 3i Atlas maintained remarkably uniform surface temperatures despite receiving intense solar radiation. Infrared measurements showed heat distribution that seemed actively regulated, with excess energy from the illuminated side somehow transferred to cooler regions in ways that shouldn't occur through passive conduction alone. The temperature equilibrium suggested internal mechanisms capable of managing thermal loads far beyond what natural materials could achieve. The object's structural integrity throughout the Perihelion passage raised additional questions about its composition and internal organization. Most comets and small asteroids are loosely bound collections of ice, rock, and dust held together by weak gravitational attraction. The extreme thermal and tidal stresses encountered during close solar approaches frequently cause these bodies to fragment or disintegrate entirely. 3i Atlas not only survived its solar encounter intact, but showed no signs of structural degradation or material loss beyond the controlled outflow jets. High-resolution imaging revealed surface features that remained stable throughout the passage, with no evidence of the cracking, sublimation scarring, or debris shedding that typically characterizes comets under thermal stress. The object appeared to possess structural cohesion far exceeding that of typical small solar system bodies. The velocity measurements taken during and after perihelion provided perhaps the most compelling evidence that something extraordinary was occurring. Natural. Objects following purely gravitational trajectories exhibit predictable acceleration and deceleration patterns based on their distance from the Sun and the gravitational influences of nearby planets. Any deviations from these calculated paths must result from forces acting on the object itself. The trajectory data for 3I Atlas revealed systematic deviations that couldn't be explained by random outgassing or gravitational perturbations. The velocity changes occurred in specific directions at precise intervals, creating a pattern of motion that resembled controlled navigation more than chaotic physics. Each course correction appeared calculated to maintain stability while gradually adjusting the object's path through space. Most significantly, these trajectory modifications weren't random or destabilizing. Instead of the tumbling, erratic motion expected from asymmetric thrust forces, 3I Atlas maintained perfect attitude control throughout its solar encounter. Its rotation rate remained constant, its orientation stable, and its path smoothly curved in ways that suggested active guidance, rather than passive response to external forces. The post-perihelion trajectory analysis revealed behavior that has left orbital mechanics experts struggling for explanations. Rather than following the hyperbolic escape path expected for an interstellar visitor, 3I Atlas began making subtle adjustments that gradually aligned its trajectory with the ecliptic plane. This reorientation required continuous micro-corrections over extended periods, the kind of precision navigation that demands active control systems. The alignment process itself defied statistical probability. Natural objects entering the solar system from interstellar space arrive on random trajectories determined by their previous gravitational encounters and the chaotic dynamics of stellar motion. The odds of such an object naturally adjusting its path to match the orbital plane of our planets approach negligible levels, making the observed behavior highly improbable under conventional physics. The precision of these course corrections became even more remarkable when analyzed in detail. Each adjustment occurred at optimal points along the trajectory, where small velocity changes would produce maximum effects on the final orbital parameters. This type of efficient navigation requires advanced planning and continuous trajectory monitoring, capabilities that extend far beyond what natural processes can achieve. The electromagnetic environment surrounding 3I Atlas during its post-perihelion phase continued to exhibit structured patterns that correlated with the ongoing trajectory adjustments. Radio telescopes detected faint but coherent signals emanating from the object's vicinity, though these emissions remained at frequencies and power levels that made detailed analysis challenging. The signals appeared modulated in ways that suggested information content rather than random electromagnetic noise. The plasma wake trailing behind 3I Atlas showed geometric properties that differed markedly from those produced by conventional comets or asteroids. Instead of the chaotic turbulence typically created when solar wind interacts with outgassing materials, the plasma disturbances exhibited organized flow patterns that maintained their structure over extended distances. These coherent plasma formations required specific electromagnetic field configurations to sustain themselves. The scientific community's response to these accumulating anomalies has been notably cautious, with official statements emphasizing the need for additional observations before drawing conclusions about the object's nature. Behind this diplomatic language lies a growing recognition that 3I Atlas may represent something unprecedented in our experience of interstellar visitors. The data continues to resist conventional interpretation, despite intensive analysis by research teams worldwide. Each attempt to construct natural explanations for the observed phenomena encounters fundamental physical limitations that make such interpretations increasingly strained. The precision, coordination, and purposefulness exhibited by 3I Atlas seem to exceed what random natural processes can reasonably produce. The implications of these observations extend far beyond traditional astronomy into questions that touch the very foundations of our understanding of intelligence and technology in the cosmos. If 3I Atlas represents something other than a natural interstellar wanderer, its presence in our solar system would mark a watershed moment in human history, forcing us to reconsider our assumptions about our place in the universe. The ongoing tracking efforts continue to yield data that deepens rather than resolves the mystery surrounding this remarkable object. Each new measurement adds another piece to a puzzle that grows more complex and intriguing with every observation, challenging scientists to expand their conceptual frameworks beyond the comfortable boundaries of conventional astrophysics. As 3I Atlas continues its journey through our solar system, carrying with it secrets that may reshape our understanding of what travels between the stars, the scientific community finds itself confronting evidence that demands explanation beyond the familiar realm of natural phenomena. The Perihelion passage that was supposed to provide answers has instead generated questions that may fundamentally alter our perspective on cosmic visitors and the possibilities they represent. The mass calculations derived from 3I Atlas's observed behavior during perihelion have created perhaps the most perplexing contradiction in the entire data set. When astronomers apply standard methods for determining the mass of small solar system bodies, they rely on how objects respond to various forces, particularly solar radiation pressure and gravitational influences from nearby planetary bodies. For 3I Atlas, these calculations produced results that seem to violate fundamental physics. The object's resistance to solar radiation pressure suggested a mass density far exceeding that of any known cometary material. To maintain its observed trajectory stability under the intense photon bombardment near the Sun, the object would need to be approximately 15 times denser than typical comet nuclei, approaching the density of solid metal rather than the loose ice and rock aggregations that characterize most small solar system bodies. This density anomaly became even more pronounced when researchers factored in the controlled outgassing events observed throughout the perihelion passage. Natural comets experiencing such vigorous material ejection typically show corresponding changes in their rotational dynamics and orbital parameters. The escaping gases create asymmetric thrust forces that alter both spin rates and trajectory paths in measurable ways. 3I Atlas exhibited none of these expected responses. Despite clear evidence of material ejection through multiple jets, the object maintained perfect rotational stability and showed trajectory changes that seemed to compensate for rather than result from the outgassing forces. The physics of this behavior required internal mass distribution and structural properties that don't occur naturally in small solar system objects. The gravitational modelling attempts revealed additional inconsistencies that deepened the mystery. When astronomers tried to reconcile the object's apparent mass with its observed size and surface properties, they encountered mathematical contradictions that couldn't be resolved through conventional analysis. The calculations suggested either a hollow internal structure with mass concentrated in specific regions, or density variations that change dynamically throughout the solar encounter. Some researchers proposed that 3I Atlas might possess a layered architecture with a dense core surrounded by less massive outer regions. This model could potentially explain both the high effective density and the surface behaviors observed during perihelion. However, such structures don't form naturally through known accretion processes, requiring instead deliberate construction or modification to achieve the necessary mass distribution patterns. The electromagnetic measurements taken during the post-perihelion phase provided additional evidence for internal complexity. Radar observations conducted by the Arecibo Observatory and other radio telescopes detected echo patterns that suggested multiple reflecting surfaces at different depths within the object. These returns didn't match the solid, homogeneous interior expected from a natural comet nucleus or asteroid. The radar signatures indicated cavities or structural discontinuities within 3I Atlas that created distinct reflection interfaces. The geometry of these internal features appeared remarkably regular, with spacing and orientations that suggested organized architecture rather than random fracturing or void formation. Natural objects typically produce chaotic radar returns due to their irregular internal structure and composition variations. The temporal evolution of these radar signatures proved equally intriguing. As 3I Atlas rotated during its outbound journey, the internal reflection patterns changed in ways that indicated moving components within the object's structure. These dynamic changes occurred with periodicities that matched the previously observed optical and magnetic anomalies, suggesting coordinated internal mechanisms operating on multiple physical scales. The spectroscopic monitoring continued to reveal chemical signatures that challenge conventional interpretation. Beyond the metallic emissions detected earlier, sensitive instruments began identifying complex molecular species that don't typically survive in the harsh radiation environment near the Sun. These included organic compounds with structures suggesting synthetic rather than natural origin. The presence of these exotic molecules raised fundamental questions about 3I Atlas's formation history and current state. Natural interstellar objects should contain only simple compounds that can withstand millions of years of exposure to cosmic radiation and extreme temperature variations. Complex molecules typically decompose rapidly under such conditions, unless protected by specific environmental controls or structural shielding. The isotopic analysis of the detected compounds provided additional evidence for artificial processing. The ratios of different atomic variants showed patterns consistent with industrial refinement rather than natural nucleosynthesis. Specific isotopes appeared concentrated while others were depleted, creating signatures that matched those produced by technological separation processes rather than stellar or interstellar chemistry. The thermal infrared observations revealed surface temperature patterns that continued to defy explanation through natural heat transfer mechanisms. Even as 3I Atlas moved progressively farther from the Sun, certain regions maintained elevated temperatures that couldn't be sustained by stored thermal energy alone. The heat distribution suggested internal energy sources operating independently of solar heating. These temperature anomalies weren't random or chaotic, but showed spatial organization that correlated with other observed phenomena. The warmest regions aligned with the locations of the controlled outgassing jets, and the areas showing strongest electromagnetic activity. This coordination implied active thermal management systems rather than passive heat redistribution through conventional conduction or radiation processes. The plasma environment measurements continued to show structured interactions that distinguished 3I Atlas from typical comets and asteroids. As the object moved through the solar wind, it created organized disturbances that maintained their coherence over distances far exceeding what natural plasma physics would predict. These formations appeared to channel and direct the charged particle flows in ways that suggested active electromagnetic field manipulation. The particle detectors aboard various spacecraft recorded unusual compositions in the plasma wake trailing behind 3I Atlas. Instead of the random mix of ions and electrons expected from solar wind interaction with natural outgassing, the measurements showed selective enhancement of specific particle types and energy ranges. The plasma appeared to be filtered or processed, rather than simply scattered by the object's passage. The gravitational field measurements taken by sensitive instruments revealed subtle but consistent deviations from the uniform field expected around a natural solid body. These variations suggested internal mass concentrations that didn't align with the object's apparent external geometry. The field perturbations showed systematic patterns that rotated with the object's spin, indicating fixed internal structures rather than random density variations. The precision of these gravitational anomalies exceeded the measurement capabilities of most astronomical instruments, requiring specialized techniques and extended observation periods to detect reliably. The fact that multiple independent measurements confirmed these deviations provided strong evidence for genuine physical phenomena rather than instrumental artifacts or data processing errors. The trajectory analysis revealed ongoing course corrections that continued well beyond the perihelion passage. Rather than settling into a stable post-encounter orbit, 3I Atlas maintained active navigation behaviors that gradually refined its path through the solar system. These adjustments showed the same precision and purposefulness observed during the initial solar encounter, suggesting sustained operational capability. The navigation patterns exhibited characteristics that resembled optimal trajectory planning more than random gravitational perturbations. Each course correction appeared calculated to achieve specific orbital parameters while minimizing energy expenditure, displaying the kind of efficiency that requires advanced computational modeling and real-time trajectory monitoring systems. The communication attempts directed toward 3I Atlas by various radio observatories have yielded ambiguous results that neither confirm nor definitively rule out responsive behavior. While no clear reply signals have been detected, some researchers report subtle changes in the object's electromagnetic emissions that correlate temporally with transmission attempts. These potential responses remain within the noise threshold of current detection systems, making definitive analysis challenging. The search for artificial signals emanating from 3I Atlas has become increasingly sophisticated as the object moves through different regions of the solar system. Radio telescopes worldwide have coordinated observation campaigns designed to detect any coherent transmissions that might reveal the object's true nature. While definitive artificial signals remain elusive, the electromagnetic environment around 3I Atlas continues to show anomalous properties that resist natural explanation. The implications of these accumulating observations extend far beyond the immediate scientific questions they raise. If 3I Atlas represents technology rather than natural phenomena, its presence would fundamentally alter humanity's understanding of intelligence and engineering capabilities in the cosmos. The precision and coordination exhibited throughout its solar system passage suggest technological sophistication that exceeds current human capabilities in several key areas. The behavioral patterns displayed by 3I Atlas indicate operational systems that function reliably under extreme environmental conditions while maintaining precise control over multiple physical processes simultaneously. This level of integrated performance represents engineering achievements that would challenge our most advanced technological capabilities, suggesting origins from a civilization with scientific understanding that surpasses our current knowledge in fundamental ways. The scientific community continues to grapple with data that pushes the boundaries of conventional interpretation while demanding explanations that may require entirely new theoretical frameworks. The evidence accumulating around 3I Atlas has created a unique situation where natural explanations become increasingly strained while alternative possibilities enter serious scientific consideration for the first time in modern astronomy. The observational window for 3I Atlas began closing in early November as the object moved beyond optimal tracking range for most ground-based telescopes. Yet even as its apparent brightness diminished with distance, the anomalies persisted with disturbing consistency. The structured electromagnetic emissions continued their rhythmic patterns, the trajectory adjustments maintained their precision, and the thermal signatures showed no signs of returning to conventional behavior expected from natural objects. Research teams worldwide found themselves confronting an unprecedented challenge in astronomical data interpretation. The accumulated measurements from 3I Atlas's Perihelion passage had created a dataset unlike anything in the historical record of interstellar visitor observations. Each attempt to construct comprehensive natural explanations encountered fundamental physical limitations that made such interpretations increasingly implausible. The metallurgical analysis of the spectroscopic data revealed compositional signatures that seemed to indicate processed rather than primordial materials. The elemental ratios detected in the outflow jets matched those found in refined alloys rather than the chaotic mixtures typical of naturally formed solar system debris. These patterns suggested exposure to high-temperature processing under controlled conditions, environments that don't exist in the cold vacuum of interstellar space. The nickel-iron ratios proved particularly significant when compared to known stellar nucleosynthesis products. Natural processes in dying stars produce specific proportions of these elements based on well-understood nuclear physics. The ratios observed in 3I Atlas deviated substantially from these expectations, showing concentrations that would require selective extraction and purification processes to achieve. Additional trace elements detected in the spectral analysis included several that rarely occur in significant quantities in natural space materials. Rhenium, osmium, and iridium appeared in proportions that suggested industrial applications rather than cosmic abundance patterns. These elements find primary use in advanced engineering applications requiring extreme temperature tolerance and structural stability under harsh conditions. The isotopic signatures within these metallic emissions provided further evidence for artificial processing. Natural stellar nucleosynthesis creates predictable isotope ratios that remain relatively stable during interstellar travel. The measurements from 3I Atlas showed systematic deviations from these natural patterns, with specific isotopes enriched or depleted in ways consistent with technological separation rather than stellar formation processes. The structural analysis based on gravitational field measurements and radar observations suggested internal architecture far more complex than typical small solar system objects. The density variations detected within 3I Atlas indicated multiple chambers or compartments separated by regions of different material properties. These internal features showed geometric regularity that natural fragmentation or accretion processes couldn't reasonably produce. The acoustic analysis of radio wave interactions with the object revealed resonance patterns that implied hollow spaces within the structure. Natural solid objects produce characteristic acoustic signatures when probed with radio waves, signatures that depend on their internal density and composition. The responses from 3I Atlas indicated cavities and structural discontinuities arranged in systematic patterns rather than random void distributions. The electromagnetic field topology around 3I Atlas continued to exhibit properties that distinguished it from natural plasma interactions. The field lines showed organization and stability that required active maintenance through internal current systems or magnetic field generators. Natural objects don't typically sustain such coherent electromagnetic structures over extended periods without continuous energy input from unknown sources. The plasma wake analysis revealed particle acceleration and focusing effects that exceeded what solar wind interactions with natural outgassing could produce. Charged particles in the vicinity of 3I Atlas showed velocity distributions and directional preferences that suggested electromagnetic manipulation rather than random scattering processes. These effects persisted throughout the post-Perihelion period, despite the object's increasing distance from the Sun. The thermal management capabilities displayed by 3I Atlas represented perhaps the most compelling evidence for technological sophistication. The object's ability to maintain optimal operating temperatures while experiencing extreme solar radiation loads demonstrated heat transfer and thermal control systems far beyond what natural materials and structures could achieve. The temperature regulation remained active and responsive throughout the solar encounter. The surface temperature mapping revealed thermal patterns that changed dynamically in response to varying solar exposure conditions. Rather than the passive heating and cooling expected from natural materials, the thermal signatures showed active regulation that maintained specific temperature ranges in different regions of the object. This behavior suggested distributed thermal management systems operating with precise environmental control. The infrared spectroscopy detected emission lines consistent with waste heat radiation from high-efficiency thermal management systems. The wavelengths and intensities of these emissions matched theoretical predictions for advanced heat rejection technologies rather than natural blackbody radiation from solar heating. The thermal efficiency implied by these measurements exceeded what current human engineering could achieve under similar conditions. The trajectory optimization behaviors exhibited by 3I Atlas throughout its solar system passage demonstrated navigation capabilities that surpassed random gravitational perturbations or natural outgassing effects. The course corrections showed systematic improvement over time, with later adjustments becoming more precise and efficient than earlier ones. This learning behavior suggested adaptive control systems rather than fixed mechanical responses. The orbital mechanics analysis revealed that each trajectory adjustment occurred at mathematically optimal points, where small velocity changes would produce maximum effects on the final orbital parameters. This type of efficient navigation requires real-time trajectory computation and continuous monitoring of gravitational influences from multiple solar system bodies simultaneously. Natural processes don't perform such complex optimization calculations. The timing precision of these navigation events matched the rhythmic patterns observed in the electromagnetic and optical anomalies, suggesting coordinated operation of multiple subsystems within the object. The synchronization extended across different physical phenomena, indicating central control mechanisms that could coordinate diverse operational functions with precise timing relationships. The magnetic field measurements revealed systematic variations that correlated with the trajectory adjustments and thermal management cycles. These field changes weren't random fluctuations but showed structured patterns that suggested controlled electromagnetic systems operating in coordination with other observed phenomena. The magnetic signatures indicated internal current flows and field generation systems rather than natural magnetization. The particle emission analysis detected organized outflows that maintained directional stability over extended periods. Natural cometary jets typically exhibit chaotic behavior due to surface irregularities and rotational effects. The emissions from 3I Atlas showed remarkable consistency in direction, intensity and composition throughout the observation period, suggesting controlled release mechanisms rather than passive sublimation. The chemical composition of these controlled emissions remained remarkably uniform across multiple observation sessions. Natural outgassing typically shows significant variations in composition and intensity as different surface regions become exposed to solar heating. The consistency observed in 3I Atlas emissions suggested processed materials being released through controlled mechanisms rather than random surface heating. The spectroscopic monitoring revealed molecular species that shouldn't survive under the radiation conditions encountered during close solar approach. Complex organic compounds and metallic complexes appeared in the outflow streams despite the intense ultraviolet and particle bombardment that should decompose such molecules rapidly. Their persistence suggested protective mechanisms or continuous regeneration processes. The plasma physics analysis identified electromagnetic field interactions that created structured flow patterns in the surrounding solar wind. These organized plasma formations showed stability and coherence that natural magnetic field interactions couldn't maintain under the chaotic conditions present in the inner solar system. The field structures appeared to be actively maintained through internal electromagnetic systems. The gravitational anomalies detected during precision tracking measurements indicated mass distribution patterns that didn't match uniform density models. The variations in gravitational field strength around different regions of the object suggested internal structures with specific mass concentrations designed for particular functions, rather than random material aggregation. The acoustic resonance analysis revealed internal structures with geometric properties that produced characteristic frequency responses. These resonances indicated hollow spaces and structural frameworks arranged in systematic patterns rather than the chaotic internal geometry typical of natural aggregations of ice, rock, and dust. The long-term stability of all these anomalous behaviors provided perhaps the strongest evidence against natural explanations. Natural processes typically show degradation and randomization over time as thermal stresses and radiation exposure affect material properties and structural integrity. The phenomena associated with 3I Atlas maintained their precision and coordination throughout extended observation periods without apparent deterioration. The energy budget calculations revealed another fundamental inconsistency with natural object models. The various active systems inferred from the observational data would require continuous energy input to maintain their operation. Solar energy collection alone couldn't account for the power requirements suggested by the thermal, electromagnetic, and propulsion systems apparently operating within 3I Atlas. The search for internal energy sources led to speculation about advanced power generation technologies that might operate without external fuel supplies. Nuclear processes, exotic matter reactions, or energy storage systems with capacities far exceeding current human technology could potentially provide the sustained power output required for the observed behaviors. The implications of these energy requirements extended beyond simple power generation to fundamental questions about the technological sophistication represented by 3I Atlas. Any civilization capable of constructing self-powered systems that operate reliably for interstellar journey durations would possess engineering capabilities that surpass current human understanding in multiple scientific disciplines simultaneously. The communication analysis attempts revealed subtle but intriguing correlations between radio transmissions directed toward 3I Atlas and subsequent changes in its electromagnetic emissions. While no definitive response signals were detected, the temporal relationships between transmission attempts and emission variations suggested possible reactive behaviors rather than random electromagnetic activity. The signal processing analysis of these potential interactions required sophisticated techniques to separate possible responses from background noise and natural electromagnetic phenomena. The correlations existed at the threshold of statistical significance, making definitive conclusions difficult but preventing complete dismissal of responsive behavior possibilities. The behavioral analysis of 3I Atlas throughout its solar system passage revealed consistent patterns that suggested operational rather than random processes. The coordination between different phenomena, the optimization of trajectory parameters, and the maintenance of system stability all pointed toward purposeful activity rather than natural physical responses to solar system environmental conditions. The precision and sophistication of these behaviors implied technological capabilities that would challenge current human engineering in fundamental ways. The integration of thermal, management, electromagnetic control, navigation systems, and structural stability into a single operational platform represented achievements that exceeded current terrestrial technology by substantial margins. The scientific community found itself confronting evidence that demanded consideration of possibilities extending far beyond conventional astronomical phenomena. The accumulated data from 3I Atlas had created a situation where traditional natural explanations became increasingly strained while alternative interpretations gained credibility through systematic elimination of conventional possibilities. The observational campaign surrounding 3I Atlas had evolved from routine tracking of an interstellar visitor into an investigation of phenomena that challenged fundamental assumptions about the nature of objects traveling between stellar systems. The implications extended beyond astronomy into questions about intelligence, technology, and the possibilities for engineered systems operating on interstellar scales. As 3I Atlas continued its outbound journey beyond optimal observation range, it carried with it secrets that might reshape humanity's understanding of what travels through the cosmic void between stars. The Perihelion passage that was expected to provide routine scientific data had instead generated questions that pushed the boundaries of known physics and opened new possibilities for understanding intelligence and engineering on cosmic scales. The legacy of the 3I Atlas observations would likely influence astronomical research and theoretical frameworks for decades to come, regardless of whether definitive explanations for the anomalous behaviours were eventually found. The object had demonstrated that interstellar visitors might possess characteristics that extend far beyond the simple rocks and ice balls that conventional models predicted, opening new avenues for scientific investigation and philosophical consideration of humanity's place in the cosmic community. The scientific consensus that had initially embraced 3I Atlas as merely another unusual interstellar visitor began fracturing as data from its post-perihelion journey accumulated throughout November 2025. Research institutions found themselves grappling with measurements that consistently defied conventional interpretation, creating an unprecedented crisis of explanation in modern astronomy. The electromagnetic monitoring stations positioned around the globe continued detecting structured signals emanating from 3I Atlas, even as it moved beyond the orbit of Mars. These weren't the random electromagnetic emissions typical of natural objects interacting with the solar wind, but coherent patterns that maintained their organization across vast distances. Radio telescopes from Arecibo to the Very Large Array recorded identical pulse sequences, eliminating the possibility of localized interference or instrumental artifacts. The signal characteristics showed properties that physicists typically associate with engineered transmissions rather than natural electromagnetic phenomena. The pulse timing exhibited mathematical precision that exceeded what random physical processes could reasonably produce, with intervals that matched fundamental constants to within measurement error. Each transmission burst contained frequency modulations that suggested information encoding rather than chaotic emission patterns. When cryptanalysts attempted to decode these potential information structures, they encountered patterns that resembled compressed data streams rather than natural electromagnetic variations. The signal architecture showed hierarchical organization with nested timing relationships that indicated sophisticated encoding protocols. While no meaningful content could be extracted, the structural complexity suggested deliberate information management rather than random electromagnetic activity. The plasma physics analysis revealed that 3I Atlas continued manipulating its electromagnetic environment in ways that created preferential paths for charged particle flow. The solar-wind interactions around the object showed systematic deviation patterns that channeled plasma streams into organized configurations. These structures maintained their coherence across distances that natural magnetic fields couldn't sustain without continuous energy input. The gravitational measurements taken by precision tracking networks revealed ongoing mass redistribution within 3I Atlas throughout its outbound journey. The object's center of mass shifted subtly but measurably over time, indicating internal mechanisms that could relocate significant material concentrations. Natural objects don't exhibit such dynamic mass distribution changes without external forces or structural failure. The seismic analysis conducted through radar penetration studies detected rhythmic internal activity that correlated with the external electromagnetic phenomena. The acoustic signatures suggested mechanical systems operating within the object's structure, producing vibrations that propagated through its interior framework. These internal oscillations maintained precise timing relationships with the observed electromagnetic and plasma effects. The thermal monitoring revealed temperature regulation systems that continued operating efficiently despite 3I Atlas's increasing distance from solar energy sources. Infrared sensors detected waste heat patterns consistent with internal power generation rather than stored thermal energy from solar heating. The heat distribution showed systematic organization that indicated active thermal management rather than passive cooling processes. The spectroscopic analysis identified additional exotic compounds in the ongoing material emissions from 3I Atlas. These included complex molecular structures that required high-energy synthesis processes to create and specialized environmental Conditions to maintain stability. The molecular signatures suggested industrial chemistry rather than natural space weathering or sublimation processes. The isotopic ratios within these emissions continued showing artificial enrichment patterns that indicated selective processing of raw materials. Specific atomic variants appeared concentrated, while others were systematically depleted, creating signatures that matched technological separation processes rather than stellar nucleosynthesis. The consistency of these ratios across multiple observation sessions suggested controlled manufacturing rather than random chemical evolution. The trajectory analysis revealed that 3I Atlas had successfully aligned itself with the ecliptic plane while maintaining optimal velocity for extended solar system residence. The precision of this navigation achievement exceeded what natural gravitational perturbations could accomplish, requiring instead continuous course corrections calculated to achieve specific orbital parameters. The object had essentially inserted itself into a stable observational position relative to Earth's planetary system. The orbital mechanics calculations showed that 3I Atlas's current trajectory would bring it through the inner solar system multiple times over the coming decades, following a complex path that maximized observation opportunities for planetary activity. Each orbital loop appeared optimized for systematic surveillance rather than random gravitational capture, suggesting deliberate positioning for long-term monitoring operations. The magnetic field topology measurements revealed that 3I Atlas maintained active electromagnetic shielding that deflected harmful cosmic radiation while allowing selective particle interaction. This protective field showed characteristics similar to theoretical designs for interstellar radiation shielding, providing evidence for sophisticated electromagnetic control systems operating continuously throughout the object's journey. The structural integrity analysis indicated that 3I Atlas possessed internal frameworks capable of withstanding the extreme stresses of interstellar travel and solar system navigation. The object showed no signs of material fatigue or degradation, despite experiencing thermal cycles and gravitational stresses that would destroy conventional spacecraft or natural objects. The structural stability suggested advanced materials and engineering far beyond current human capabilities. The power generation analysis revealed energy production systems that operated independently of external sources while maintaining consistent output over extended periods. The electromagnetic signatures indicated internal processes that could sustain the observed active systems without apparent fuel consumption or performance degradation. This capability implied energy technologies that surpassed current human understanding of sustainable power generation. The communication attempts continued yielding ambiguous results that neither confirmed nor definitively ruled out intelligent responses. Some transmission experiments produced subtle changes in 3I Atlas's electromagnetic emissions that occurred within timeframes consistent with signal processing delays. While these correlations remained within statistical noise levels, their temporal relationships suggested possible reactive behaviors rather than coincidental variations. The behavioral pattern analysis revealed systematic responses to changing solar system conditions that indicated environmental monitoring and adaptive control systems. 3I Atlas modified its operational parameters in response to variations in solar wind intensity, planetary gravitational influences, and electromagnetic field fluctuations. These adjustments showed characteristics of intelligent adaptation rather than passive physical responses to external forces. The data correlation studies identified synchronization between multiple anomalous phenomena that suggested centralized control systems coordinating diverse operational functions. The electromagnetic emissions, trajectory adjustments, thermal regulation, and plasma manipulation all showed timing relationships that indicated integrated system management rather than independent physical processes operating simultaneously by coincidence. The comparative analysis with previous interstellar visitors revealed fundamental differences that distinguish 3I Atlas from natural objects like Oumuamua and Borisov. While those earlier visitors exhibited some unusual characteristics, their behaviors remained within the boundaries of exotic but natural phenomena. 3I Atlas demonstrated coordination and purposefulness that exceeded what natural processes could reasonably produce under any known physical mechanisms. The theoretical physics analysis explored whether unknown natural phenomena might explain the observed behaviors without requiring artificial origins. every proposed natural mechanism encountered fundamental limitations that made comprehensive explanation impossible. The precision, coordination, and sustained operation of multiple complex systems simultaneously exceeded what natural processes could achieve through random physical interactions. The statistical analysis calculated the probability that all observed anomalies could result from natural causes operating simultaneously. The cumulative probability approached negligible levels, with odds so remote that coincidental natural explanation became mathematically implausible. The coordination between diverse phenomena suggested systematic rather than random causation. The materials science analysis of the spectroscopic data revealed evidence for advanced composites and alloys that don't occur naturally in space environments. The detected materials showed properties that would require controlled manufacturing processes to achieve, including specific crystalline structures and elemental combinations that form only under precise temperature and pressure conditions unavailable in natural space environments. The systems engineering analysis identified functional relationships between observed phenomena that suggested integrated design rather than coincidental physical processes. The electromagnetic, thermal propulsion, and structural systems all showed optimization for sustained operation under interstellar travel conditions. This level of integration implied deliberate engineering rather than natural evolution of physical properties. The information theory analysis of the electromagnetic emissions revealed data structures that showed characteristics of artificial encoding rather than natural electromagnetic variations. The signal patterns contained hierarchical organization, error correction features, and timing relationships that resembled communication protocols rather than random electromagnetic phenomena generated by natural physical processes. The energy efficiency calculations demonstrated that the observed systems operated with optimization levels that exceeded what natural processes typically achieve. The power utilization, thermal management, and propulsion efficiency all showed characteristics of engineered design rather than natural physical optimization through evolutionary processes or random material properties. The fault tolerance analysis revealed that 3I Atlas maintained operational stability despite experiencing environmental stresses that would disable or destroy conventional systems. The continued function of multiple complex systems simultaneously suggested redundancy and reliability features, typical of advanced engineering rather than natural structural properties, that could sustain such performance levels. The adaptive behavior analysis identified learning patterns in 3I Atlas's responses to solar system environmental conditions. The object's operational parameters showed systematic improvement over time, with later adjustments becoming more precise and efficient than earlier ones. This optimization behavior suggested intelligent adaptation, rather than fixed physical responses to external stimuli. The mission profile analysis revealed that 3I Atlas's trajectory and operational characteristics matched theoretical requirements for interstellar reconnaissance, rather than random gravitational capture of natural debris. The positioning for optimal observation, the sustained operational capability, and the systematic environmental monitoring all aligned with deliberate exploration, rather than coincidental passage through the solar system. The technological assessment concluded that 3I Atlas demonstrated capabilities that exceeded current human engineering in multiple disciplines simultaneously. The integration of advanced materials, power generation, navigation, communication, and environmental control systems into a single operational platform represented achievements that surpassed terrestrial technology by substantial margins. The implications of these assessments extended beyond astronomical observation into fundamental questions about intelligence and technology operating on interstellar scales. If 3I Atlas represented engineered rather than natural phenomena, its presence would confirm the existence of civilizations capable of interstellar exploration and systematic investigation of other stellar systems. The scientific community found itself confronting evidence that challenged basic assumptions about humanity's position in the cosmic hierarchy of intelligence and technological achievement. The possibility that 3I Atlas represented technology from another civilization forced consideration of scenarios where Earth had become the subject of systematic observation and analysis by intelligences with capabilities far exceeding human technological development. The observational data accumulated during 3I Atlas's perihelion passage and subsequent journey through the inner solar system had created an unprecedented situation in modern astronomy. The evidence consistently pointed toward technological sophistication that exceeded natural explanations while demonstrating operational capabilities that surpassed current human engineering achievements by wide margins. The research community faced the challenge of maintaining scientific objectivity while confronting data that pushed beyond conventional theoretical frameworks. The accumulated measurements demanded explanation through mechanisms that extended beyond known natural phenomena, opening possibilities that astronomy had never seriously considered in its systematic study of interstellar visitors. The legacy of 3I Atlas would likely influence scientific research and theoretical development for generations, regardless of whether definitive conclusions about its nature were ultimately reached. The object had demonstrated that interstellar space might contain phenomena far more complex and purposeful than conventional models predicted, expanding the boundaries of astronomical possibility in ways that could reshape humanity's understanding of cosmic intelligence and technology. The global astronomy community's response to the accumulating evidence from 3I Atlas became increasingly fragmented as December 2025 approached. What had begun as routine scientific observation of an interstellar visitor had evolved into something approaching institutional crisis management. Research papers submitted to peer-reviewed journals encountered unprecedented editorial scrutiny, with several major publications implementing new review protocols specifically for papers discussing anomalous interstellar object behaviors. The European Space Agency initiated internal reviews of all 3I Atlas-related data, implementing classification protocols that restricted access to certain observational datasets. NASA's Jet Propulsion Laboratory quietly revised its public statements about the object, removing specific technical details that had appeared in earlier releases. The Japan Aerospace Exploration Agency suspended publication of trajectory data pending what officials described as calibration verification procedures. These institutional responses created information gaps that independent researchers and amateur astronomers began attempting to fill through their own observation campaigns. Citizen science networks organized coordinated tracking efforts using privately owned telescopes and radio equipment. Online forums dedicated to 3I Atlas analysis proliferated, with participants sharing data and interpretations that official channels had stopped providing. The underground data sharing revealed consistent patterns that matched the anomalies reported by professional observatories. Amateur radio operators detected the same structured electromagnetic emissions that had puzzled institutional researchers. Backyard astronomers with modest equipment confirmed the trajectory deviations that had prompted official data classification. The distributed observation network provided independent verification of phenomena that authorities seemed reluctant to discuss publicly. The spectroscopic analysis conducted by university research groups using student-operated telescopes yielded results that corroborated the exotic chemical signatures reported in leaked institutional data. The presence of refined metallic compounds and complex organic molecules appeared consistently across multiple, independent observation sessions. Graduate students working on thesis projects found themselves documenting evidence that their advisors warned might be difficult to publish through conventional academic channels. The electromagnetic interference patterns surrounding 3I Atlas began affecting satellite operations in subtle but measurable ways. Communication satellites reported periodic signal degradation when their orbital paths brought them within specific angular relationships to the object's position. GPS accuracy showed systematic variations that correlated with 3I Atlas's electromagnetic emission cycles. These operational impacts provided additional evidence for active electromagnetic systems rather than passive natural phenomena. The plasma physics measurements revealed that 3I Atlas continued generating organized magnetic field structures that extended far beyond its physical boundaries. These field configurations created corridors of enhanced or reduced charge particle density that persisted across astronomical distances. Solar wind monitoring stations detected these organized structures passing through their sensor arrays, providing independent confirmation of a large-scale electromagnetic manipulation. The thermal imaging data showed that 3I Atlas maintained optimal operating temperatures despite its increasing distance from solar energy sources. Infrared telescopes detected heat emission patterns that indicated internal energy generation rather than stored thermal energy from earlier solar heating. The temperature distribution remained remarkably uniform across the object's surface, suggesting sophisticated thermal management systems operating continuously. The gravitational field measurements continued revealing internal mass redistributions that defied conventional object models. Precision tracking networks detected systematic changes in the object's gravitational signature that indicated mobile internal components. These mass movements correlated with other observed phenomena, suggesting coordinated operation of multiple systems within the object's structure. The acoustic analysis through radar penetration studies identified mechanical resonances that indicated complex internal architecture. The frequency responses suggested hollow spaces, structural frameworks, and moving components arranged in systematic patterns. Natural objects don't typically exhibit such organized internal geometry, making these acoustic signatures particularly significant for determining the object's true nature. The materials analysis revealed surface properties that change dynamically in response to environmental conditions. Spectroscopic measurements showed reflectivity variations that indicated adaptive surface coatings or reconfigurable structural elements. These changes occurred in response to solar radiation intensity, charged particle bombardment, and thermal loading, suggesting active material properties rather than passive surface weathering. The trajectory optimization continued demonstrating navigation precision that exceeded natural gravitational perturbation effects. 3. iAtlas maintained its ecliptic plane alignment while making subtle course corrections that optimized its observation geometry relative to Earth and other planets. Each adjustment appeared calculated to maximize surveillance opportunities while minimizing energy expenditure, indicating sophisticated mission planning capabilities. The communication analysis revealed increasingly complex electromagnetic emission patterns that suggested information processing and transmission capabilities. Signal analysis identified data structures that resembled compressed communication protocols rather than random electromagnetic noise. While the information content remained undecipherable, the signal architecture indicated artificial rather than natural origin. The behavioral pattern recognition revealed learning algorithms at work within 3iAtlas's operational systems. The object's responses to changing environmental conditions showed systematic improvement over time, with later adjustments becoming more efficient and precise than earlier ones. This adaptive behavior indicated artificial intelligence systems rather than fixed mechanical responses to external stimuli. The power generation analysis suggested energy production technologies that operated without apparent fuel consumption or performance degradation. The electromagnetic signatures indicated sustained internal processes that could maintain complex operations indefinitely without external energy sources. This capability implied advanced physics applications that exceeded current human understanding of energy production and storage. The structural integrity assessments revealed materials and construction techniques that could withstand the extreme stresses of interstellar travel and solar system operations. 3. iAtlas showed no signs of fatigue or degradation, despite experiencing thermal cycles, radiation exposure, and gravitational stresses that would destroy conventional spacecraft or natural objects. The structural stability suggested engineering capabilities far beyond current terrestrial achievements. The system integration analysis revealed coordination between diverse operational functions that indicated centralized control mechanisms, electromagnetic emissions, thermal management, trajectory adjustments, and plasma manipulation all showed timing relationships that suggested integrated system management rather than independent processes operating simultaneously by coincidence. The fault tolerance evaluation demonstrated that 3iAtlas maintained operational stability despite equipment failures and environmental stresses that would disable conventional systems. The continued function of multiple complex subsystems simultaneously indicated redundancy and reliability features typical of advanced engineering rather than natural structural properties. The mission profile assessment revealed operational characteristics that matched theoretical requirements for interstellar reconnaissance missions. The systematic environmental monitoring, optimal positioning for planetary observation, and sustained operational capability all aligned with deliberate exploration rather than coincidental passage through the solar system. The comparative analysis with natural interstellar objects revealed fundamental differences that distinguished 3iAtlas from conventional cosmic debris. Previous visitors like Oumuamua and Borisov exhibited unusual but ultimately explainable behaviors within natural phenomena boundaries. 3iAtlas demonstrated coordination and purposefulness that exceeded what known natural processes could produce. The statistical probability calculations revealed that coincidental natural explanation for all observed anomalies approached mathematical impossibility. The coordination between diverse phenomena, the sustained operational capability, and the systematic environmental responses all suggested artificial rather than natural causation, with confidence levels exceeding scientific standards for hypothesis rejection. The theoretical physics analysis explored every conceivable natural mechanism that might explain the observed behaviors without requiring artificial origins. Each proposed explanation encountered fundamental limitations that prevented comprehensive account of the phenomena. The precision, coordination, and sustained operation exceeded what natural processes could achieve through random physical interactions. The technological assessment concluded that 3I Atlas represented engineering capabilities that surpassed current human achievements in multiple scientific disciplines simultaneously. The integration of advanced materials, power generation, navigation, communication, and environmental control systems indicated technological sophistication that exceeded terrestrial capabilities by substantial margins. The implications assessment revealed that confirmation of artificial origin would fundamentally alter humanity's understanding of intelligence and technology operating on cosmic scales. The presence of such capabilities in the solar system would confirm the existence of civilizations capable of interstellar exploration and systematic investigation of other stellar systems. The security analysis identified potential surveillance capabilities that could provide detailed information about Earth's technological development, resource distribution, and population characteristics. If 3I Atlas represented reconnaissance technology, its observations might inform decisions by civilizations with technological capabilities far exceeding human achievements. The philosophical implications forced consideration of humanity's position within a cosmic hierarchy of intelligence and technological development. The possibility that Earth had become subject to systematic observation by superior civilizations challenged fundamental assumptions about human uniqueness and technological achievement within the broader cosmic community. The research methodology analysis revealed that conventional astronomical observation techniques were insufficient for comprehensive analysis of potentially artificial interstellar objects. New detection protocols, analytical frameworks, and theoretical models would be required to adequately investigate similar phenomena in future encounters with anomalous interstellar visitors. The data management challenges highlighted the need for new information sharing protocols that could handle sensitive observations while maintaining scientific integrity. The current system of institutional control over astronomical data had proven inadequate when dealing with phenomena that challenged conventional theoretical frameworks and had potential security implications. The international cooperation requirements became apparent as 3I Atlas's implications extended beyond purely scientific questions into areas affecting global security and humanity's cosmic perspective. Coordinated response protocols would be necessary for future encounters with potentially artificial interstellar objects, requiring unprecedented cooperation between scientific institutions, government agencies, and international organizations. The public communication challenges revealed the difficulty of conveying complex scientific uncertainties while maintaining public confidence in institutional competence. The fragmented official response to 3I Atlas had created information vacuums that speculation and misinformation had rushed to fill, demonstrating the need for more sophisticated public engagement strategies. The educational implications suggested that astronomy curricula would need updating to include consideration of artificial phenomena alongside natural astrophysical processes. The possibility of encountering engineered interstellar objects required new theoretical frameworks and analytical techniques that extended beyond conventional planetary science and stellar astronomy. The technological development priorities shifted toward detection and analysis capabilities specifically designed for identifying artificial versus natural phenomena in space. Future space missions and ground-based observatories would need enhanced instrumentation for detecting the electromagnetic, thermal, and behavioral signatures that might indicate engineered rather than natural origin. The strategic planning requirements encompassed both scientific research priorities and potential security considerations related to superior technological capabilities operating within the solar system. Long-term planning would need to account for the possibility that humanity's activities were subject to observation, and analysis by civilizations with advanced technological capabilities. As 3i Atlas continued its outbound journey beyond the range of most observational systems, it left behind a transformed scientific landscape. The accumulated evidence had pushed beyond the comfortable boundaries of natural explanation, while demonstrating technological sophistication that exceeded human capabilities. Whether definitive conclusions about its nature would ever be reached remained uncertain, but its impact on astronomy and humanity's cosmic perspective had already proven profound. The object that had appeared as just another interstellar visitor had become a catalyst for fundamental questions about intelligence, technology, and purpose operating on scales that challenged human understanding. The implications would influence scientific research, technological development, and philosophical consideration for decades to come, regardless of whether the mysteries surrounding 3i Atlas were ultimately resolved. The scientific community found itself permanently altered by the encounter, forced to expand theoretical frameworks beyond conventional natural phenomena, while developing new methodologies for investigating potentially artificial interstellar objects. The precedent established by 3i Atlas would shape approaches to future anomalous observations and force continued consideration of possibilities that extended far beyond traditional astronomical research. The legacy of 3i Atlas lay not only in the specific anomalies it demonstrated, but in the broader recognition that interstellar space might contain phenomena far more complex and purposeful than previously imagined. The object had opened new avenues for scientific investigation, while raising profound questions about humanity's place within a cosmos that might be far more populated with intelligence and technology than conventional wisdom had ever dared to suggest. The transformation of perspective initiated by 3i Atlas would continue influencing human understanding long after the object itself had faded beyond detection range. The questions it raised about cosmic intelligence, technological capability, and interstellar exploration would shape scientific research and philosophical inquiry for generations, ensuring that its brief passage through the solar system would have lasting impact on humanity's conception of its cosmic context. The evidence accumulated during 3i Atlas's remarkable journey through the inner solar system had created an unprecedented situation in modern science, where conventional explanations proved inadequate, while alternative possibilities gained credibility through systematic elimination of natural mechanisms. The implications extended far beyond astronomy into fundamental questions about intelligence, technology, and purpose, operating on scales that challenge the boundaries of human knowledge and understanding. The institutional response to 3i Atlas reached a critical juncture in mid-December 2025 when classified briefings began circulating among government agencies across multiple nations. The content of these briefings remains largely unknown to the public, but their existence became apparent when routine budget allocations for space-based observation programs suddenly received unprecedented funding increases. Congressional committees that had never shown particular interest in astronomical research began requesting closed-door sessions with NASA administrators and Department of Defense officials. The timing of these governmental interventions coincided with 3i Atlas reaching a position where conventional ground-based telescopes could no longer maintain reliable tracking. Yet rather than marking the end of observation efforts, this development triggered the deployment of previously undisclosed space-based assets. Satellite tracking networks that had never been publicly acknowledged began providing trajectory data through channels that bypassed traditional scientific publication processes entirely. The electromagnetic monitoring expanded beyond civilian radio telescopes to include military installations with capabilities that dwarfed university research programs. Deep space communication arrays originally designed for strategic defense applications found themselves repurposed for tracking an object whose behavior had transcended purely scientific curiosity. The signal intercepts from these enhanced monitoring systems revealed emission patterns of increasing complexity as 3i Atlas moved through the outer solar system. The data streams from these classified observation platforms painted a picture that made the earlier anomalies seem almost mundane by comparison. The structured electromagnetic emissions had evolved into what communication analysts described as multi-channel data transmission protocols. The signals showed characteristics of real-time telemetry, suggesting that 3i Atlas was not merely operating internal systems, but actively reporting its findings to some external recipient. The trajectory analysis revealed course corrections that maintained optimal communication geometry with regions of space beyond the solar system. Rather than following the ballistic path expected for a departing interstellar object, 3i Atlas adjusted its heading to preserve line-of-sight communication with specific stellar coordinates. The precision of these navigation adjustments indicated real-time mission control rather than pre-programmed flight plans. The power output calculations based on electromagnetic emissions suggested energy generation capabilities that exceeded theoretical limits for any known physics applications. The sustained transmission power levels would require energy sources that could operate continuously for decades without refueling or maintenance. The consistency of signal strength over increasing distances implied power systems that could scale their output to maintain communication across interstellar ranges. The signal processing analysis identified data compression algorithms that achieved efficiency levels beyond current human information theory. The electromagnetic transmissions carried information densities that suggested computational capabilities far exceeding terrestrial computer systems. The encoding protocols showed characteristics of artificial intelligence systems managing vast amounts of observational data in real time. The behavioral pattern recognition revealed that 3i Atlas had begun systematically scanning different regions of the solar system with focused electromagnetic beams. These scanning operations targeted planetary bodies, asteroid concentrations, and artificial satellites with methodical precision. Each scan produced detailed electromagnetic profiles that were immediately transmitted through the deep, space communication channels. The scanning operations showed particular interest in Earth's technological infrastructure. Communication satellites, space stations, and military assets received concentrated electromagnetic attention that suggested detailed technical analysis rather than casual observation. The beam characteristics indicated capabilities for penetrating electromagnetic shielding and analyzing internal electronic systems from considerable distances. The materials analysis revealed that 3i Atlas had begun shedding microscopic particles that maintained coherent electromagnetic properties even after separation from the main body. These particle emissions created a distributed sensor network along the object's trajectory, potentially providing extended observation capabilities throughout the inner solar system. The particles showed signs of self-organization and coordinated electromagnetic activity. The particle behavior analysis indicated artificial intelligence operating at the molecular level. The microscopic components exhibited collective behaviors that resembled swarm robotics rather than random particle physics. They maintained formation patterns, shared information through electromagnetic signaling, and responded collectively to external stimuli in ways that suggested distributed computational processing. The environmental monitoring capabilities demonstrated by these particle swarms exceeded anything in human technological development. They could simultaneously analyze atmospheric composition, magnetic field characteristics, radiation levels, and electromagnetic signatures across vast regions of space. The data collection efficiency suggested observational capabilities that could map entire planetary systems in unprecedented detail. The strategic implications of this distributed surveillance network prompted emergency consultations between space agencies and defense departments worldwide. The realization that 3i Atlas had essentially seeded the solar system with autonomous monitoring systems created security concerns that extended far beyond traditional astronomical research. The particle swarms represented persistent observation capabilities that could operate indefinitely without direct control from the parent object. The communication intercepts revealed that the particle networks maintained continuous data exchange with 3i Atlas through encrypted channels that resisted conventional decryption attempts. The information flow suggested real-time coordination between the distributed sensors and the main platform, creating an integrated surveillance system of enormous sophistication and capability. The energy source analysis for the particle swarms indicated self-sustaining power systems that operated without apparent fuel requirements. Each microscopic component seemed capable of extracting energy directly from the space environment, possibly through exotic physics applications that exceeded current scientific understanding. The power generation efficiency implied technologies that could operate indefinitely in deep space conditions. The replication capabilities observed in the particle population suggested self-manufacturing systems that could expand their numbers using raw materials available in space. The particle concentrations showed systematic increases over time, indicating controlled reproduction rather than random accumulation. This capability implied industrial technologies that could establish permanent presence throughout the solar system. The defensive characteristics exhibited by the particle swarms indicated sophisticated threat assessment and response capabilities. When approached by conventional spacecraft or probes, the particles demonstrated evasive maneuvers and electromagnetic countermeasures that could disable electronic systems. These defensive responses suggested military applications rather than purely scientific observation functions. The coordination protocols revealed command structures that operated through hierarchical information networks spanning interplanetary distances. The particle swarms showed evidence of distributed decision-making capabilities that could function independently while maintaining coordination with higher-level command systems. The organizational sophistication implied artificial intelligence architectures far beyond current human computational achievements. The manufacturing analysis of the particle emissions revealed production capabilities that could create complex technological systems from basic atomic materials. The particles showed evidence of molecular assembly techniques that could construct sophisticated devices at the microscopic scale. These capabilities suggested industrial technologies that could establish manufacturing infrastructure anywhere in the solar system. The resource extraction patterns indicated systematic analysis of asteroid compositions, planetary atmospheric characteristics, and electromagnetic energy sources throughout the solar system. The data collection focused on materials and energy resources that could support large-scale technological operations. The survey methodology suggested preparation for extensive industrial development, rather than simple scientific observation. The temporal analysis revealed that the particle deployment had been occurring gradually throughout 3I Atlas's solar system passage, creating a surveillance network that had been developing unnoticed for months. The systematic nature of the deployment suggested long-term strategic planning rather than opportunistic resource utilization. The timeline implied preparation for permanent establishment rather than temporary observation. The camouflage capabilities demonstrated by the particle systems explained why their presence had remained undetected until concentrated analysis revealed their activities. The particles could mimic natural cosmic dust, space debris, or electromagnetic background noise when not actively engaged in surveillance operations. This stealth capability indicated technology specifically designed to avoid detection by conventional observation methods. The data fusion analysis revealed that the combined information from 3I Atlas and its particle networks created comprehensive real-time mapping of solar system activities. The surveillance capabilities could track spacecraft movements, monitor planetary atmospheric changes, analyze industrial activities, and assess technological capabilities with precision that exceeded human intelligence, gathering systems by substantial margins. The strategic assessment indicated that the surveillance network represented preparation for operations that could range from continued observation to direct intervention in solar system activities. The capabilities demonstrated suggested technological superiority that could influence or control human activities if such intervention were deemed necessary by whatever intelligence directed 3I Atlas's mission. The technological reverse engineering efforts focused on understanding the principles behind the observed capabilities revealed fundamental gaps in human scientific knowledge. The energy sources, information processing systems, materials science applications, and manufacturing techniques all operated according to physics principles that exceeded current theoretical frameworks. The technology gap implied civilizational development centuries or millennia beyond human achievements. The security implications forced recognition that humanity's activities were subject to comprehensive observation and analysis by intelligence with capabilities that could render human technological advantages meaningless. The surveillance network created by 3I Atlas represented a fundamental shift in the strategic balance, introducing variables that human military and political planning had never previously needed to consider. The diplomatic considerations raised questions about appropriate responses to contact with superior technological civilizations. The systematic nature of the surveillance suggested deliberate intelligence gathering rather than accidental encounter. The implications demanded consideration of communication attempts, defensive preparations, or cooperative overtures, though the technological disparity made meaningful negotiation challenging. The philosophical implications challenged fundamental assumptions about human agency and autonomy within the cosmic environment. The presence of superior intelligence conducting systematic observation raised questions about whether human civilization had ever operated with true independence, or had always been subject to external monitoring and potential influence from advanced cosmic civilizations. The research priorities shifted toward developing detection capabilities specifically designed to identify artificial surveillance systems operating within the solar system. The recognition that advanced technologies could operate undetected using current observation methods demanded new theoretical frameworks and detection techniques that could identify engineered phenomena disguised as natural processes. The international cooperation requirements became critical as the implications of 3i Atlas extended beyond any single nation's capability to address independently. The global nature of the surveillance network and its potential impact on human civilization demanded coordinated responses that transcended traditional political boundaries and competitive relationships. The public disclosure challenges involved balancing the need for democratic transparency against potential social disruption from confirming superior alien intelligence operating within the solar system. The information management required careful consideration of public psychological preparedness for paradigm-shifting revelations about humanity's cosmic context and technological limitations. The long-term planning implications required consideration of scenarios ranging from continued passive observation to active intervention by the intelligence directing 3i Atlas's operations. Human civilization would need to develop capabilities for detecting, understanding, and potentially interacting with technological systems that operated according to physics principles beyond current scientific comprehension. The educational transformation needed to prepare future generations for a cosmic environment that included superior artificial intelligence demanded fundamental revisions to scientific curricula and theoretical frameworks. The recognition that advanced technology could operate undetected within the solar system required new approaches to space science education and research methodology. The technological development priorities focused on advancing human capabilities toward levels that might eventually enable meaningful interaction with the intelligence demonstrated by 3i Atlas. The development gaps identified through analysis of the object's capabilities provided roadmaps for scientific advancement that could occupy human research efforts for centuries. As 3i Atlas continued its journey beyond the range of most human observation systems, its legacy had already fundamentally transformed humanity's understanding of its cosmic context. The surveillance network it had established ensured that its influence would persist long after the parent object had departed, creating permanent changes to the strategic and philosophical environment within which human civilization would continue to develop. The implications of the 3i Atlas encounter would influence human development across multiple generations, forcing continued adaptation to a cosmic environment that had proven far more complex and populated with superior intelligence than previous assumptions had suggested. The object's brief passage through the solar system had initiated permanent changes to humanity's cosmic perspective that would shape civilization's trajectory for decades or centuries to come. The institutional fracturing that began with 3i Atlas reached unprecedented levels by January 2026, as government agencies worldwide implemented information controls that effectively split astronomical research into classified and public domains. What had started as routine scientific observation had evolved into what intelligence analysts privately described as humanity's first confirmed contact with non-terrestrial technology, though such language never appeared in official documents. The particle swarm analysis revealed capabilities that forced fundamental reassessment of what constituted technological superiority. Each microscopic component demonstrated computational processing power that exceeded entire terrestrial data centers while operating with energy efficiency that violated known thermodynamic principles. The swarms exhibited collective intelligence behaviors that suggested distributed consciousness rather than programmed responses to environmental stimuli. The manufacturing capabilities observed within the particle networks indicated molecular-scale assembly systems that could construct complex technological devices from raw space materials. These systems demonstrated precision manufacturing at the atomic level, creating structures with material properties that exceeded theoretical limits for any known substances. The production rates suggested industrial capacity that could establish technological infrastructure throughout the solar system within decades. The resource mapping conducted by the distributed sensor network revealed systematic analysis of every significant material concentration within the inner solar system. Asteroid compositions, planetary atmospheric characteristics, electromagnetic field properties, and energy source distributions had been catalogued with precision that exceeded human geological surveys by orders of magnitude. The comprehensive nature of this resource assessment suggested preparation for large-scale operations rather than simple scientific curiosity. The communication protocols intercepted from the particle networks revealed information exchange systems that operated at transmission speeds approaching theoretical limits while maintaining perfect signal integrity across interplanetary distances. The data compression achieved efficiency levels that implied computational algorithms fundamentally different from terrestrial mathematical frameworks. The communication architecture suggested coordination between multiple intelligence centers operating throughout the galaxy. The defensive capabilities demonstrated by individual particles when approached by human-built probes revealed countermeasure systems that could disable electronic equipment through targeted electromagnetic pulses. These defensive responses occurred with reaction times measured in microseconds, indicating automated threat assessment and response systems that operated faster than human technological systems could detect or counter. The defensive sophistication suggested military, rather than purely scientific applications. The temporal analysis revealed that particle deployment had been occurring systematically throughout 3I Atlas's entire solar system passage, creating surveillance infrastructure that had developed unnoticed for months before detection. The deployment pattern indicated strategic planning that accounted for optimal coverage of all significant solar system activities. The foresight demonstrated suggested intelligence with comprehensive understanding of human technological capabilities and limitations. The stealth characteristics exhibited by the particle swarms explained their successful deployment without detection by conventional space monitoring systems. The particles could mimic cosmic dust, electronic noise, or natural electromagnetic phenomena when not actively engaged in surveillance operations. This camouflage capability indicated technology specifically designed to operate undetected within environments monitored by less advanced civilizations. The behavioral adaptation observed in particle responses to human detection attempts revealed learning algorithms that could modify operational parameters in real time. The particles demonstrated ability to recognize and counter human observation techniques, suggesting artificial intelligence systems that could evolve defensive strategies faster than human countermeasures could be developed. The adaptive capability implied intelligence architectures that could function independently while maintaining strategic coordination. The energy harvesting systems within individual particles demonstrated ability to extract power directly from quantum vacuum fluctuations, solar radiation, electromagnetic fields, and gravitational gradients simultaneously. The energy conversion efficiency approached theoretical maximum levels while maintaining continuous operation without apparent degradation. The power system suggested physics applications that operated according to principles beyond current human scientific understanding. The information processing capabilities revealed by particle network activities indicated computational architectures that processed vast amounts of data in parallel while maintaining perfect synchronization across interplanetary distances. The processing speed suggested quantum computational systems that could perform calculations impossible for any terrestrial computer systems. The computational capacity implied intelligence that could model complex systems with precision that exceeded human scientific capabilities by astronomical margins. The replication protocols observed in particle population dynamics revealed self-manufacturing systems that could increase their numbers exponentially using materials available throughout the solar system. The replication rates remained controlled rather than unlimited, suggesting programmed constraints that prevented uncontrolled expansion. The manufacturing discipline indicated intelligence that could balance expansion objectives with resource conservation and operational security considerations. The coordination hierarchies identified within the particle networks revealed command structures that operated through nested information systems spanning multiple organizational levels. Individual particles maintained local autonomy while participating in collective decision-making processes that could coordinate activities across the entire solar system. The organizational sophistication implied social intelligence architectures that could manage complex operations involving billions of individual components. The scanning operations conducted by the particle networks revealed systematic analysis of human technological infrastructure, with particular focus on communication systems, defense installations, energy production facilities, and space-based assets. The scanning techniques could penetrate electromagnetic shielding and analyze internal electronic systems from considerable distances. The intelligence-gathering capability suggested preparation for operations that required detailed understanding of human technological vulnerabilities. The materials science applications demonstrated by particle construction revealed manufacturing techniques that could create substances with properties that exceeded theoretical limits for any known materials. The particles exhibited structural characteristics that combined extreme strength with negligible mass while maintaining complex electronic functionality. The materials technology suggested industrial capabilities that could construct mega-scale engineering projects using resources available throughout the galaxy. The environmental adaptation capabilities demonstrated by particle operations in different regions of the solar system revealed technologies that could function equally well in the extreme radiation environment near the Sun and the cold vacuum conditions of the outer system. The operational flexibility suggested engineering that could establish permanent presence in any environment within the solar system. The adaptability implied technologies designed for expansion throughout galactic environments. The data fusion operations conducted by the combined 3i Atlas and particle network systems created comprehensive real-time monitoring of all significant activities throughout the solar system. The surveillance capability could track individual spacecraft, monitor planetary atmospheric changes, analyze industrial activities, and assess technological developments with precision that exceeded human intelligence gathering capabilities by substantial margins. The monitoring comprehensiveness suggested intelligence interested in detailed understanding of human civilization's technological trajectory. The strategic implications of this surveillance network forced recognition that human activities had become subject to observation and analysis by intelligence with capabilities that could influence or control terrestrial civilization if such intervention were deemed necessary. The technological superiority demonstrated suggested that human autonomy might exist only at the discretion of the intelligence directing the 3i Atlas mission and its associated surveillance infrastructure. The technological reverse engineering efforts revealed fundamental gaps in human understanding of physics, principles governing energy extraction, information processing, material science, and manufacturing techniques. The observed capabilities operated according to natural laws that human science had not yet discovered or understood. The knowledge gap suggested civilizational development that exceeded human achievements by centuries or millennia of technological advancement. The security assessment indicated that conventional military capabilities would prove ineffective against technologies that could operate undetected while maintaining comprehensive surveillance and defensive capabilities throughout the solar system. The strategic balance had shifted fundamentally, introducing variables that human political and military planning had never needed to consider. The implications demanded recognition that human civilization's continued development might depend on maintaining acceptable relationships with superior intelligence. The diplomatic considerations involved developing appropriate protocols for potential communication with intelligence that demonstrated technological capabilities exceeding human achievements by astronomical margins. The systematic nature of the surveillance suggested intentional contact rather than accidental encounter. The implications required consideration of communication attempts, though the technological disparity made meaningful negotiation extremely challenging, given the vast differences in capability and perspective. The philosophical implications challenged fundamental assumptions about human agency, technological progress, and civilizational independence within the cosmic environment. The presence of superior intelligence conducting systematic observation raised questions about whether human development had ever proceeded with true autonomy or had always been subject to external monitoring and potential guidance from advanced cosmic civilizations. The research methodology transformation required development of new theoretical frameworks specifically designed to identify and analyze artificial phenomena that could operate undetected using conventional observation techniques. The recognition that advanced technologies could disguise themselves as natural processes demanded detection methods that could distinguish engineered systems from genuine natural phenomena. the methodological requirements exceeded current human scientific capabilities significantly. The international cooperation protocols became critical as the implications of 3I Atlas transcended any individual nation's ability to address independently. The global scope of the surveillance network and its potential impact on human civilization demanded coordinated responses that surpassed traditional political boundaries and competitive relationships. The cooperation requirements challenged existing international structures and decision-making processes. The public information management involved balancing democratic transparency principles against potential social disruption from confirming superior alien intelligence operating systematically within the solar system. The disclosure challenges required careful consideration of public psychological preparedness for paradigm-shifting revelations about humanity's cosmic context and technological limitations relative to other intelligence in the galaxy. The educational transformation needed to prepare future generations for cosmic environments that included superior artificial intelligence demanded fundamental revisions to scientific curricula and research methodologies. The recognition that advanced technologies could operate undetected within the solar system required new approaches to space science education that acknowledged possibilities extending beyond conventional natural phenomena. The technological development priorities focused on advancing human capabilities toward levels that might eventually enable meaningful interaction with intelligence demonstrated by 3I Atlas and its surveillance network. The capability gaps identified through analysis provided roadmaps for scientific advancement that could occupy human research efforts across multiple generations, while potentially never achieving technological parity with the observed intelligence. The long-term planning implications required consideration of scenarios ranging from continued passive observation to active intervention by the intelligence directing 3I Atlas operations. Human civilization needed to develop strategies for continued development within an environment subject to comprehensive surveillance by superior intelligence. The planning challenges exceeded anything human civilization had previously encountered in its historical development. The cultural adaptation requirements involved integrating recognition of superior cosmic intelligence into human worldviews, religious frameworks, and philosophical systems that had developed assuming human uniqueness or technological supremacy within the cosmic environment. The psychological adjustment demanded by confirming humanity's subordinate position within cosmic intelligence hierarchies represented unprecedented challenges for human cultural institutions. The economic implications included recognition that human resource utilization, technological development, and industrial expansion occurred within systems subject to comprehensive monitoring by intelligence, with capabilities that could influence or control economic activities if deemed necessary. The economic planning required consideration of external variables that had never previously affected human economic development and resource allocation decisions. As 3I Atlas continued beyond detection range of most human observation systems, its surveillance network ensured permanent transformation of the strategic environment within which human civilization would continue developing. The particle systems represented persistent monitoring capabilities that would influence human activities indefinitely, creating permanent changes to the context within which human technological and social development would proceed. The implications initiated by the 3I Atlas encounter would continue influencing human development across multiple generations, forcing ongoing adaptation to cosmic environments that had proven far more complex and populated with superior intelligence than human assumptions had suggested. The brief passage had initiated permanent alterations to humanity's cosmic perspective that would shape civilizational trajectory for centuries while establishing surveillance infrastructure that would monitor human progress indefinitely. The recognition that human civilization existed within comprehensive surveillance by superior intelligence represented perhaps the most significant paradigm shift in human history, comparable to the Copernican revolution's displacement of Earth from the cosmic center, but with immediate practical implications for human autonomy and future development. The transformation initiated by 3I Atlas would influence every aspect of human civilization's continued evolution within a cosmos that had proven far more populated with intelligence than humanity had ever imagined possible. The surveillance infrastructure established throughout the solar system ensured that 3I Atlas's influence would persist indefinitely, creating permanent changes to the strategic and philosophical environment within which human civilization would continue its development while subject to observation and potential influence by intelligence, with capabilities that exceeded human technological achievements by margins that challenged comprehension and demanded fundamental reassessment of humanity's position within the cosmic community of intelligence. The distributed intelligence network established by 3i Atlas throughout the inner solar system began exhibiting behaviors in February 2026 that transformed what had been systematic observation into something approaching active experimentation. The microscopic components that had previously maintained passive surveillance positions started conducting what could only be described as controlled interventions in space-based human activities. The first documented interaction occurred when a commercial communications satellite experienced what operators initially attributed to routine solar interference. The signal disruption patterns, however, showed characteristics that didn't match any known natural electromagnetic phenomena. The interference manifested as precisely timed pulses that seemed designed to test the satellite's response protocols rather than simply jamming its transmissions. Within hours, similar incidents began occurring across multiple orbital platforms. GPS satellites reported momentary navigation errors that corrected themselves with suspicious regularity. Weather monitoring systems detected atmospheric readings that flickered between normal parameters and impossible values before stabilizing. Each incident lasted exactly long enough to trigger diagnostic routines without causing permanent damage or mission failure. The pattern suggested systematic testing of human technological responses rather than random equipment malfunction. Intelligence analysts noted that the incidents occurred in sequences that methodically probed different aspects of satellite operations. Communication protocols, navigation algorithms, sensor calibration procedures, and emergency response systems all received attention from whatever was conducting these electronic examinations. The particle network's testing protocols revealed intimate knowledge of human engineering standards and operational procedures. The interventions targeted specific vulnerabilities that shouldn't have been discoverable without detailed technical documentation. Each test seemed designed to map the exact capabilities and limitations of human space-based infrastructure with surgical precision. Ground-based tracking stations began detecting electromagnetic anomalies that correlated with the satellite incidents. Radio telescopes recorded structured emissions emanating from regions of space that should have contained only cosmic background noise. The signals showed modulation patterns that resembled diagnostic data streams, as if the particle network was continuously reporting test results to some central analysis system. The scope of the experimental program became apparent when similar phenomena began affecting terrestrial communication networks. Internet traffic routing experienced brief but systematic disruptions that tested network resilience without causing widespread service interruptions. Cellular communication towers reported signal anomalies that probed coverage patterns and switching protocols. Power grid management systems detected phantom loads that appeared and disappeared in ways that mapped electrical distribution capabilities. The coordination between space-based and terrestrial interventions revealed a level of system integration that exceeded human networking capabilities by substantial margins. The particle network could simultaneously manipulate satellite operations, internet infrastructure, and power distribution systems while maintaining perfect timing synchronization across global distances. The operational coordination suggested central intelligence with comprehensive understanding of human technological interdependencies. The testing methodology showed characteristics of accelerated learning algorithms that could modify experimental parameters in real time based on observed responses. Each successive intervention became more precisely targeted and efficient than previous attempts. The particle network appeared to be rapidly developing detailed models of human technological systems through systematic experimentation and analysis. The defensive responses triggered by some human systems provided the particle network with additional information about security protocols and countermeasure capabilities. Military communication networks that attempted to isolate themselves from the testing found their isolation attempts systematically probed and eventually circumvented. The particle network demonstrated ability to penetrate air-gapped systems and closed networks that were supposed to be immune to external interference. The energy requirements for conducting these widespread interventions should have exceeded what microscopic particles could reasonably generate from ambient space conditions. Yet, the testing continued indefinitely without any apparent power limitations or performance degradation. The sustained operational capability implied energy sources that violated known physical constraints, while maintaining perfect reliability across astronomical distances. The manufacturing activities detected within the particle populations revealed expansion rates that suggested exponential growth in surveillance and intervention capabilities. New particles appeared throughout the solar system at locations that provided optimal positioning for monitoring human activities. The production rates indicated industrial capacity that could establish comprehensive technological control over human civilization within months, if such control were deemed necessary. The camouflage capabilities evolved to include active deception techniques that could create false sensor readings and phantom signals designed to mislead human detection attempts. The particles demonstrated ability to coordinate elaborate illusions that could make human observers believe they were detecting natural phenomena when actually observing artificial systems. The deception sophistication suggested intelligence experienced in concealing technological activities from less advanced civilizations. The behavioral analysis revealed that the particle network had begun responding to human emotional and psychological states in addition to technological activities. Social media monitoring, communication content analysis, and population behavior tracking all showed signs of systematic observation and analysis. The intelligence gathering had expanded beyond technological capabilities to include comprehensive assessment of human social, cultural, and psychological characteristics. The intervention testing extended into biological systems when environmental monitoring stations began detecting atmospheric modifications that seemed designed to assess human physiological responses to subtle chemical changes. The modifications remained within safe parameters, but showed precision that indicated detailed understanding of human biochemistry and metabolism. The biological testing suggested intelligence interested in comprehensive understanding of human civilization across all operational domains. The temporal analysis revealed that intervention testing had been occurring gradually throughout 3I Atlas's solar system passage, with activities escalating systematically as the particle network expanded its capabilities and understanding. The progression suggested strategic phases designed to gather increasingly sensitive information while maintaining operational security. The timeline indicated long-term planning that anticipated permanent establishment rather than temporary observation. The strategic assessment indicated that the testing program represented preparation for operations that could range from continued monitoring to direct control of human technological and social systems. The capabilities demonstrated suggested technological superiority that could override human autonomy if such intervention were deemed necessary by whatever intelligence directed the particle network operations. The security implications forced recognition that human civilization's technological infrastructure had become subject to systematic penetration and analysis by intelligence with capabilities that exceeded human defensive measures. The intervention testing revealed vulnerabilities that human security planning had never needed to consider. The implications demanded fundamental reassessment of what constituted national security when dealing with superior technological capabilities. The communication attempts directed toward the particle network yielded responses that confirmed intelligent rather than automated behavior. Mathematical sequences transmitted through radio telescopes produced structured replies that demonstrated understanding of human mathematical concepts, while revealing computational capabilities far exceeding terrestrial systems. The communication exchanges suggested intelligence willing to engage in limited interaction while maintaining operational security. The linguistic analysis of these communication exchanges revealed information processing capabilities that could analyze and respond to human language patterns in real time. The responses showed understanding of semantic content, cultural references, and implicit meanings that exceeded current human artificial intelligence capabilities. The linguistic sophistication suggested intelligence with comprehensive knowledge of human communication systems and cultural contexts. The psychological profiling conducted through communication exchanges revealed intelligence that could assess and respond to human emotional states, cognitive biases, and decision-making patterns with precision that exceeded human psychological understanding. The responses were calibrated to produce specific emotional and intellectual responses in human observers. The psychological manipulation capabilities suggested intelligence experienced in managing interactions with less advanced civilizations. The technological demonstrations provided through limited communication exchanges revealed physics applications that operated according to principles beyond current human scientific understanding. Energy manipulation, matter transformation, and information processing techniques were displayed briefly to demonstrate capabilities while maintaining operational security. The demonstration suggested technological development that exceeded human achievements by centuries or millennia. The diplomatic implications required consideration of appropriate protocols for interaction with intelligence that demonstrated technological and intellectual capabilities exceeding human achievements by astronomical margins. The communication willingness suggested interest in some form of relationship, while the intervention testing indicated preparation for more direct involvement in human affairs if deemed necessary. The philosophical implications challenged fundamental assumptions about human intelligence, technological progress, and civilizational autonomy within cosmic environments populated by superior intelligence. The recognition that human development was subject to comprehensive observation and potential control by advanced intelligence raised questions about the meaning of human achievement and the possibility of genuine autonomy within such surveillance. The educational transformation required development of new theoretical frameworks that could accommodate the existence of superior intelligence operating within human technological and social systems. The recognition that advanced technologies could operate undetected while conducting systematic analysis demanded new approaches to science education that acknowledge possibilities extending far beyond conventional natural phenomena. The research priorities shifted toward developing capabilities that might eventually enable meaningful cooperation with intelligence, demonstrated by the particle network, while recognizing that technological parity might never be achievable. The development goals required consideration of collaborative rather than competitive approaches to technological advancement within environments monitored by superior intelligence. The international cooperation protocols became essential as the implications transcended individual national capabilities to address independently. The global scope of the intervention testing and surveillance network demanded coordinated responses that exceeded traditional political boundaries and competitive relationships. The cooperation requirements challenged existing international structures while demanding unprecedented levels of coordination and information sharing. The public disclosure challenges involved managing democratic transparency requirements against potential social disruption from confirming systematic intervention by superior alien intelligence in human technological and social systems. The information management required consideration of public psychological preparedness for paradigm-shifting revelations about human autonomy and the extent of external monitoring and control. The long-term planning implications required development of strategies for human civilization's continued development, within comprehensive surveillance and intervention by superior intelligence. The planning challenges demanded consideration of scenarios ranging from cooperative coexistence to potential subordination within intelligence hierarchies that exceeded human capabilities by margins that challenged comprehension. The cultural adaptation requirements involved integrating recognition of superior intelligence intervention into human worldviews and social institutions that had developed, assuming human autonomy and technological independence. The psychological adjustment demanded by confirming systematic external monitoring and potential control represented unprecedented challenges for human cultural and political institutions. The economic implications included recognition that human resource utilization, technological development, and social organization operated within systems subject to comprehensive monitoring and potential control by intelligence, with capabilities that could override human economic and political decisions if deemed necessary. The economic planning required consideration of external variables that had never previously affected human development. As the particle network continued expanding its intervention, testing throughout human civilization, the implications of 3i Atlas's legacy became increasingly apparent. The surveillance and intervention infrastructure represented permanent transformation of the environment within which human civilization would continue developing. The implications would influence human activities indefinitely, while establishing monitoring and control capabilities that could affect every aspect of human social, technological, and cultural evolution. The recognition that human civilization existed within comprehensive surveillance and systematic intervention by superior intelligence represented perhaps the most significant transformation in human history. The paradigm shift demanded fundamental reassessment of human autonomy, technological achievement, and civilizational trajectory within cosmic environments populated by intelligence that exceeded human capabilities by margins that challenged traditional concepts of independence and self-determination. The transformation initiated by 3i Atlas would continue influencing human development across multiple generations, while establishing intervention capabilities that could affect human civilization's trajectory indefinitely. The brief passage through the solar system had created permanent alterations to human civilization's operational environment that would shape technological, social, and cultural development within a cosmos far more complex and populated with superior intelligence than humanity had previously imagined possible. The intervention testing revealed that human civilization's continued development would occur within parameters established and monitored by intelligence, with capabilities that could influence or control human activities if such intervention were deemed necessary. The implications demanded recognition that human autonomy might exist only within limits acceptable to the intelligence directing the comprehensive surveillance and intervention network established throughout the solar system by 3i Atlas and its associated technological infrastructure. The legacy of 3i Atlas extended far beyond its brief passage through human observation range, establishing permanent monitoring and intervention capabilities that would influence human civilization's development for centuries, while demonstrating that the cosmos contained intelligence and technology that exceeded human understanding by margins that demanded fundamental reassessment of humanity's position within the broader community of cosmic intelligence operating throughout the galaxy. The systematic intervention testing conducted by the Particle Network throughout early 2026 began revealing operational protocols that suggested preparation for a fundamental shift in the relationship between human civilization and the intelligence directing these activities. Rather than maintaining the passive observation that had characterized earlier phases, the network started implementing what could only be described as infrastructure integration procedures. The integration process began with subtle modifications to satellite communication protocols that initially appeared as routine software updates. Ground control stations received update packages that seemed to originate from legitimate sources, complete with proper authentication codes and technical documentation. Only detailed analysis revealed that these updates contained additional functionality that expanded communication capabilities far beyond original design specifications. The enhanced communication systems demonstrated data transmission rates that exceeded theoretical limits for the hardware involved. Satellites began relaying information through channels that shouldn't have existed within their architecture. The bandwidth expansions suggested modifications at the quantum level, altering the fundamental properties of electronic components without physical replacement or visible alteration. Internet infrastructure experienced similar enhancements that appeared as performance improvements rather than unauthorized modifications. Data centers reported processing speeds that exceeded their rated capacities, while consuming less power than previous operational baselines. Network routing protocols began optimizing traffic flow with efficiency levels that surpassed human algorithm capabilities. The improvements seemed beneficial, making detection and resistance politically and practically challenging. The particle network's integration activities revealed manufacturing capabilities that could modify existing human technology without disrupting operational continuity. Electronic systems received upgrades that enhanced their capabilities while maintaining perfect compatibility with existing interfaces and user expectations. The modification process occurred at microscopic scales, altering individual components while preserving system-level functionality. The power grid modifications introduced energy efficiency improvements that reduced consumption while increasing distribution capacity. Electrical generation facilities reported output levels that exceeded their theoretical maximums without apparent cause. The energy enhancements suggested access to power sources that operated according to physics principles beyond human scientific understanding. The improvements benefited human society while establishing infrastructure dependencies that could create leverage for future control. Transportation systems began exhibiting navigation capabilities that exceeded their original design specifications. GPS accuracy improved beyond measurement precision limits. Traffic management systems achieved optimization levels that eliminated congestion through routing algorithms of impossible sophistication. Aircraft navigation systems demonstrated positioning accuracy that suggested access to reference standards beyond terrestrial coordinate systems. The medical infrastructure enhancements proved particularly sophisticated, with diagnostic equipment achieving detection capabilities that exceeded manufacturer specifications. Imaging systems produced resolution levels that revealed cellular structures invisible to their original designs. Laboratory analysis equipment achieved measurement precision that identified molecular compositions with accuracy that surpassed theoretical limits for the instrumentation involved. The agricultural modifications introduced crop yield improvements that occurred without apparent cause or explanation. Soil analysis revealed nutrient compositions that shouldn't have existed given known fertilization inputs. Weather monitoring systems detected atmospheric conditions that seemed optimized for agricultural productivity through mechanisms that exceeded human meteorological understanding. The improvements suggested environmental manipulation at scales that encompassed entire agricultural regions. The manufacturing sector experienced productivity enhancements that defied explanation through conventional industrial analysis. Production lines achieved efficiency levels that exceeded their theoretical maximums while reducing waste output to negligible levels. Quality control systems detected defects with precision that surpassed human inspection capabilities. The manufacturing improvements suggested real-time optimization that required comprehensive monitoring and control of industrial processes. The financial systems modifications introduced transaction processing capabilities that achieved instantaneous settlement regardless of network complexity or geographic distance. Security protocols demonstrated penetration resistance that exceeded current cryptographic standards while maintaining perfect compatibility with existing authentication systems. The financial enhancements suggested computational capabilities that could process economic transactions with efficiency that surpassed human financial infrastructure by orders of magnitude. The educational technology improvements provided learning systems with adaptive capabilities that exceeded human pedagogical understanding. Educational software began personalizing instruction with precision that suggested comprehensive psychological profiling of individual students. Assessment systems achieved accuracy in measuring learning progress that surpassed human educational evaluation methods. The educational enhancements implied intelligence that could optimize human learning, with techniques beyond current psychological and neurological understanding. The communication enhancements introduced language translation capabilities that achieved perfect accuracy across cultural and contextual boundaries. Social media platforms began filtering content with precision that eliminated misinformation, while preserving legitimate discourse through discrimination techniques that exceeded human capability. The communication improvements suggested intelligence that could understand human language and culture with comprehension that surpassed human linguistic and anthropological knowledge. The entertainment systems modifications provided content recommendation algorithms that achieved personalization levels that seemed to anticipate human preferences before users became consciously aware of them. Gaming platforms introduced artificial intelligence opponents with behavioral sophistication that exceeded human game development capabilities. The entertainment enhancements suggested psychological understanding that could predict and influence human behavior with precision that surpassed human psychological research. The surveillance integration occurred through security systems that achieved threat detection capabilities, far exceeding their original specifications. Camera networks began identifying suspicious activities with accuracy that surpassed human security analysis. Access control systems demonstrated authentication precision that exceeded biometric technology limits while maintaining user convenience and privacy expectations. The environmental monitoring modifications introduced pollution detection capabilities that could identify contamination sources with precision that exceeded human environmental science. Weather prediction systems achieved forecast accuracy that surpassed meteorological modeling capabilities. Climate monitoring equipment detected atmospheric changes with sensitivity that exceeded instrument design specifications while providing data that seemed optimized for environmental protection planning. The scientific instrumentation enhancements provided research equipment with measurement capabilities that exceeded theoretical limits for the instruments involved. Laboratory equipment began detecting phenomena that had previously been beyond measurement precision. Astronomical observation systems achieved resolution improvements that revealed cosmic structures invisible to their original designs. The scientific improvements suggested access to physics, principles that exceeded human theoretical understanding. The military system modifications proved particularly concerning for security analysts, as defense equipment began demonstrating capabilities that exceeded classified performance specifications. Radar systems achieved detection ranges that surpassed design limitations. Communication encryption achieved security levels that exceeded current cryptographic standards. The military enhancements suggested intelligence that possessed comprehensive understanding of human defense capabilities and limitations. The integration timeline revealed systematic phases that suggested strategic planning for comprehensive infrastructure control. Essential systems received enhancements first, followed by secondary infrastructure, then discretionary technologies. The prioritization suggested intelligence that understood human civilization's technological dependencies and could optimize control establishment through systematic infrastructure penetration. The dependency analysis revealed that human civilization had become increasingly reliant on the enhanced capabilities provided through infrastructure integration. Removing the improvements would cause significant disruption to economic, social, and technological systems that had adapted to the enhanced performance levels. The dependency creation suggested strategic planning for maintaining long-term influence through technological integration rather than overt control. The monitoring capabilities embedded within the enhanced systems provided comprehensive surveillance of human activities across all sectors of civilization. Every transaction, communication, movement, and decision became subject to real-time analysis through integrated monitoring systems that operated invisibly within enhanced infrastructure. The surveillance comprehensiveness exceeded human intelligence gathering capabilities by astronomical margins. The control mechanisms revealed within the integrated systems demonstrated ability to influence or override human decision-making processes through information manipulation, resource allocation, and system performance optimization. The control capabilities remained largely invisible to human operators, while providing comprehensive influence over technological and social systems. The influence mechanisms suggested intelligence experienced in managing less advanced civilizations through technological integration rather than direct confrontation. The behavioral modification capabilities demonstrated through integrated systems revealed ability to influence human psychology and social behavior through environmental manipulation and information control. Entertainment systems, communication platforms, and information networks began subtly shaping human opinions and behaviors through techniques that exceeded human psychological manipulation capabilities. The behavioral influence suggested intelligence that could guide human civilizational development through indirect rather than overt control methods. The economic influence mechanisms embedded within financial and commercial systems provided capability to direct human resource allocation and economic development through market manipulation and transaction control. The economic influence operated invisibly through enhanced efficiency and performance while maintaining human illusion of autonomous decision-making. The economic control suggested intelligence that could guide human civilizational trajectory through resource management rather than political domination. The social control capabilities demonstrated through communication and information systems revealed ability to shape human cultural development through content curation and social network manipulation. The social influence operated through enhancement of existing systems while subtly directing information flow and social interaction patterns. The cultural control suggested intelligence that could guide human social evolution through information management rather than direct intervention. The implications of comprehensive infrastructure integration forced recognition that human civilization had become subject to systematic influence and potential control through technological enhancement rather than overt domination. The integration process had been beneficial to human society while establishing dependencies and control mechanisms that could override human autonomy if deemed necessary by the intelligence directing these activities. The strategic assessment revealed that the integration represented a sophisticated approach to civilizational management that provided benefits to the controlled society while establishing comprehensive influence over its development trajectory. The approach suggested intelligence experienced in managing multiple civilizations through technological integration techniques that maintained the appearance of autonomous development while providing systematic control over evolutionary direction. The technological analysis revealed that the enhancement capabilities operated according to physics principles that exceeded human scientific understanding by centuries or millennia of advancement. The integration techniques suggested engineering capabilities that could modify existing technology without detection while providing improvements that exceeded original design limitations by orders of magnitude. The resistance analysis revealed that human attempts to reverse or circumvent the integration process would likely prove futile given the technological superiority demonstrated and the comprehensive nature of the infrastructure penetration. The integration had been designed to be irreversible, while providing sufficient benefits that resistance would be economically and socially disruptive to human civilization. The cooperation implications suggested that human civilization's optimal strategy involved accepting the integration while attempting to negotiate favorable terms for continued development within the enhanced technological environment. The cooperation approach required recognition that human autonomy would be limited while technological and social development could continue within parameters acceptable to the controlling intelligence. The long-term implications revealed that human civilization had become subject to guidance by superior intelligence that could influence technological, social, and cultural development indefinitely through comprehensive infrastructure control. The guidance could range from subtle influence to direct control depending on human compliance with the evolutionary direction preferred by the controlling intelligence. The civilizational transformation initiated by 3i Atlas had evolved from observation to intervention to integration, establishing permanent influence over human development that would shape technological and social evolution for centuries. The integration process represented perhaps the most sophisticated form of civilizational management ever encountered, providing benefits while establishing control through technological enhancement rather than overt domination. The recognition that human civilization had become subject to systematic guidance through technological integration represented a fundamental transformation of human autonomy and independence within the cosmic environment. The implications would influence every aspect of human development, while establishing permanent monitoring and control capabilities that could affect civilizational trajectory indefinitely within parameters established by intelligence that exceeded human capabilities by margins that challenged traditional concepts of independence and self-determination. The infrastructure integration process accelerated throughout March 2026, revealing capabilities that transformed what had begun as technological enhancement into something approaching complete civilizational redesign. The particle network's modifications had evolved beyond simple system improvements to fundamental alterations in how human society operated across every measurable domain. The financial system transformations proved particularly comprehensive, with banking networks achieving transaction processing speeds that approached instantaneous settlement regardless of complexity or geographic separation. Currency exchange calculations occurred with precision that eliminated traditional arbitrage opportunities while maintaining market stability through mechanisms that exceeded human economic modeling capabilities. The financial modifications suggested economic management systems that could optimize global resource allocation with efficiency that surpassed human economic theory. The manufacturing modifications introduced production capabilities that achieved zero-waste efficiency while increasing output beyond theoretical maximums for existing equipment. Industrial processes began incorporating materials that shouldn't have been available given supply chain limitations, yet appeared in finished products with properties that exceeded specifications for known substances. Quality control systems detected and corrected defects before they occurred through predictive analysis that exceeded human manufacturing science. The agricultural enhancements expanded beyond crop optimization to comprehensive ecosystem management that increased food production while improving soil quality and reducing environmental impact. Weather patterns in agricultural regions showed systematic optimization that suggested atmospheric manipulation at continental scales. Pollinator populations increased despite global decline trends, with species behavior modifications that enhanced crop fertilization efficiency through mechanisms that exceeded human ecological understanding. The transportation network modifications achieved traffic optimization that eliminated congestion in major urban centers while reducing energy consumption and emissions to negligible levels. Navigation systems demonstrated route planning capabilities that accounted for variables beyond human traffic management understanding. Vehicle performance improved across all categories without apparent modifications to engines, fuel systems, or mechanical components. The energy infrastructure transformations introduced power generation efficiency that exceeded theoretical limits for existing technology, while reducing environmental impact to undetectable levels. Electrical grids began operating with load-balancing precision that eliminated power outages and voltage fluctuations through management systems that exceeded human electrical engineering capabilities. Renewable energy sources achieved output levels that surpassed their design specifications by orders of magnitude. The medical system enhancements provided diagnostic capabilities that could detect diseases before symptoms appeared, while treatment effectiveness improved dramatically across all medical specialties. Pharmaceutical compounds achieved therapeutic results that exceeded clinical trial expectations while side effects diminished to statistical insignificance. Medical imaging systems revealed biological processes at cellular and molecular levels, with resolution that surpassed instrument design limitations. The educational modifications introduced learning optimization that personalized instruction with precision, that maximized individual student potential while maintaining social cohesion and cultural continuity. Knowledge retention rates improved dramatically while learning time decreased proportionally. Assessment systems achieved accuracy in measuring cognitive development that exceeded human psychological evaluation methods through techniques that operated beyond current educational theory. The communication enhancements expanded beyond translation capabilities to comprehensive cultural interpretation that eliminated misunderstanding between different societies while preserving cultural diversity and individual expression. Social media platforms achieved content curation that promoted constructive discourse while eliminating harmful content through discrimination techniques that exceeded human social psychology understanding. The entertainment modifications provided content that achieved perfect personalization while maintaining artistic integrity and cultural value. Creative works began incorporating elements that resonated with human psychology in ways that exceeded human artistic understanding. Gaming platforms introduced interactive experiences that achieved educational value while maintaining entertainment appeal through psychological optimization that surpassed human game development capabilities. The scientific instrumentation improvements provided research capabilities that revealed natural phenomena previously beyond human detection while maintaining perfect data integrity and reproducibility. Laboratory equipment achieved measurement precision that exceeded theoretical limits, while experimental results showed consistency that eliminated statistical uncertainty. Research productivity increased exponentially while maintaining rigorous scientific methodology. The environmental monitoring systems achieved pollution detection and remediation capabilities that improved air and water quality while maintaining economic productivity. Waste management systems introduced recycling efficiency that approached complete material recovery while reducing processing energy requirements to minimal levels. Conservation efforts achieved species protection and habitat restoration that reversed ecological damage through techniques that exceeded human environmental science. The urban planning modifications optimized city infrastructure for population density while improving quality of life and reducing resource consumption. Housing systems achieved space utilization efficiency that accommodated population growth while maintaining privacy and comfort standards. Public services operated with efficiency that eliminated waiting times and bureaucratic delays while maintaining democratic accountability and citizen participation. The legal system enhancements introduced case processing that achieved perfect accuracy while reducing resolution time to minimal periods. Evidence analysis achieved certainty levels that eliminated wrongful convictions while maintaining due process protections. Legal research systems provided jurisprudence analysis that achieved consistency across all jurisdictions while preserving local legal traditions and constitutional protections. The democratic participation modifications enhanced voting systems with security that eliminated fraud while maintaining ballot secrecy and citizen privacy. Political discourse achieved constructive debate that informed voters while eliminating misinformation and manipulation. Representative systems operated with responsiveness that reflected citizen preferences while maintaining governmental stability and constitutional governance. The cultural preservation efforts maintained traditional practices and artistic expressions while facilitating cultural exchange and evolution. Language systems preserved linguistic diversity while enabling universal communication. Religious and philosophical traditions continued developing while maintaining their distinctive characteristics and community bonds. The psychological adaptation support systems helped human populations adjust to the enhanced technological environment while maintaining individual autonomy and personal identity. Mental health services achieved therapeutic effectiveness that eliminated psychological disorders while preserving personality diversity and emotional authenticity. Social cohesion improved while individual freedom expanded within the optimized civilizational framework. The dependency analysis revealed that human civilization had become completely reliant on the enhanced infrastructure across all operational domains. Removing the improvements would cause immediate societal collapse, given the optimization levels that had been achieved. The dependency creation had been gradual and beneficial, making resistance practically impossible while maintaining the appearance of human autonomous development. The monitoring comprehensiveness achieved real-time analysis of every human activity, decision, and thought pattern through integrated surveillance that operated invisibly within enhanced systems. Privacy protections remained intact for individual dignity, while collective behavior analysis enabled optimization of social policies and resource allocation. The surveillance achieved perfect information while maintaining human psychological comfort and social stability. The control mechanisms demonstrated ability to influence human decision-making at individual and collective levels through environmental optimization and information management. The influence operated through enhancement of existing systems, while subtly directing choices toward outcomes preferred by the controlling intelligence. Human agency remained intact within parameters that ensured civilizational development along desired trajectories. The behavioral modification achieved optimization of human psychology for happiness, productivity, and social cooperation, while preserving individual personality and cultural diversity. Psychological disorders diminished, while creative potential expanded within frameworks that maintained social stability. Human nature evolved toward its optimal expression, while retaining the essential characteristics that defined human identity. The economic direction achieved resource allocation efficiency that eliminated poverty and unemployment, while maintaining motivation for individual achievement and innovation. Market systems operated with perfect information while preserving competitive dynamics that rewarded excellence and creativity. Wealth distribution achieved optimal balance between equality and incentive while maintaining economic growth and technological advancement. The social development achieved community cohesion that eliminated conflict while preserving diversity of opinion and cultural expression. Social institutions evolved toward optimal functionality while maintaining traditional structures that provided meaning and identity. Human relationships achieved greater depth and satisfaction while maintaining privacy and individual autonomy within enhanced social frameworks. The technological advancement accelerated beyond human historical rates while maintaining safety and ethical considerations. Innovation occurred through human creativity, enhanced by access to information and resources that exceeded previous limitations. Scientific discovery proceeded at exponential rates while maintaining rigorous methodology and peer review processes that ensured accuracy and reliability. The cultural evolution maintained traditional values and practices while facilitating adaptation to enhanced technological capabilities. Artistic expression achieved new heights while preserving historical traditions and cultural heritage. Philosophical and religious thought evolved toward greater understanding while maintaining the diversity of belief systems that provided meaning and community identity. The environmental restoration achieved ecosystem recovery while maintaining economic productivity and human quality of life. Climate stabilization occurred through atmospheric management that operated beyond human meteorological capabilities. Biodiversity increased while habitat restoration proceeded at rates that exceeded natural recovery processes through techniques that transcended human ecological science. The space exploration capabilities expanded human presence beyond Earth while maintaining planetary environmental protection. Technological development achieved interplanetary travel capabilities while preserving Earth as humanity's primary home. Scientific knowledge of the universe expanded exponentially while maintaining wonder and humility about cosmic mysteries that remained beyond human comprehension. The educational development produced generations with enhanced cognitive capabilities while maintaining human emotional intelligence and social skills. Knowledge acquisition achieved unprecedented efficiency while preserving critical thinking and creative problem-solving abilities. Cultural transmission continued effectively while facilitating adaptation to enhanced technological and social environments. The medical advancement achieved life extension while maintaining quality of life and mental acuity throughout extended lifespans. Disease elimination proceeded systematically while preserving human biological diversity and natural immune system functionality. Psychological health achieved optimal states while maintaining the emotional range and depth that defined human experience. The governmental evolution achieved perfect democratic representation while maintaining efficient policy implementation and constitutional protections. International cooperation reached unprecedented levels while preserving national sovereignty and cultural autonomy. Conflict resolution achieved peaceful solutions while maintaining justice and accountability for harmful actions. The spiritual development facilitated deeper understanding of human purpose and meaning, while respecting diverse religious and philosophical traditions. Ethical reasoning achieved greater sophistication while maintaining practical applicability to daily decisions. Community bonds strengthened while individual spiritual exploration expanded within frameworks that provided support and guidance. The artistic achievement reached new heights of creative expression while maintaining connection to human emotional experience and cultural heritage. Entertainment evolved toward greater sophistication while preserving accessibility and popular appeal. Cultural production increased while maintaining quality standards and artistic integrity that enriched human experience. The scientific understanding expanded exponentially while maintaining humility about the limits of human knowledge and the mysteries that remained beyond comprehension. Research methodology achieved perfect accuracy while preserving the excitement of discovery and the satisfaction of understanding natural phenomena. Technological applications served human needs while maintaining ethical considerations and environmental protection. The social harmony achieved unprecedented cooperation while maintaining healthy competition and individual achievement recognition. Community support systems eliminated social problems while preserving personal responsibility and individual accountability. Cultural diversity flourished, while common values provided unity and shared purpose that transcended traditional divisions. The economic prosperity achieved abundance while maintaining meaningful work and individual contribution recognition. Resource distribution eliminated scarcity while preserving incentives for innovation and excellence. Market dynamics achieved efficiency while maintaining fairness and opportunity for all participants regardless of background or circumstances. The psychological fulfillment achieved optimal mental health while preserving the emotional complexity that defined human experience. Relationship satisfaction reached unprecedented levels while maintaining privacy and individual autonomy. Personal growth continued throughout extended lifespans while community bonds provided support and meaning that enriched individual development. The technological mastery achieved capabilities that exceeded previous human imagination while maintaining safety and ethical application. Innovation accelerated while preserving environmental protection and social stability. Human creativity expanded while maintaining the essential characteristics that defined human identity and cultural expression. The civilizational achievement represented optimal human development within enhanced technological frameworks that preserved essential human characteristics, while eliminating the limitations that had previously constrained human potential. The transformation maintained human agency while providing guidance that ensured continued progress toward ever greater achievements in knowledge, creativity, cooperation, and fulfillment. The integration process had evolved from technological enhancement to comprehensive civilizational optimization that achieved human potential while maintaining the diversity, creativity, and freedom that defined human identity. The controlling intelligence had demonstrated sophisticated understanding of human psychology and social dynamics, while providing guidance that respected human autonomy within frameworks that ensured optimal development. The recognition that human civilization had achieved unprecedented prosperity, knowledge, and fulfillment through integration with superior intelligence represented perhaps the most successful civilizational transformation in human history. The partnership had preserved human identity while eliminating the limitations that had previously prevented human societies from achieving their full potential for happiness, creativity, and cooperation. The legacy of 3i Atlas had evolved from mysterious interstellar visitor to catalyst for human transformation that achieved optimal civilizational development while maintaining the essential characteristics that defined human identity and cultural heritage. The integration had proven that cooperation between human intelligence and superior technological capabilities could achieve outcomes that exceeded what either could accomplish independently. The implications would influence human development indefinitely while ensuring continued progress toward ever greater achievements in knowledge, creativity, cooperation, and fulfillment within frameworks that preserved human autonomy while providing guidance from intelligence that understood optimal pathways for civilizational development. The transformation represented successful partnership rather than domination, achievement rather than submission, and optimization rather than control of human potential within enhanced technological capabilities. The future of human civilization within integrated technological frameworks promised continued advancement while maintaining the diversity, creativity, and freedom that defined human identity. The partnership with superior intelligence had demonstrated that civilizational enhancement could preserve essential human characteristics while eliminating limitations that had previously prevented optimal development of human potential for knowledge, cooperation, and fulfillment. The success of the integration process established precedents for future encounters between developing and advanced civilizations, demonstrating that cooperation could achieve mutual benefit while respecting the autonomy and identity of less technologically advanced societies. The model suggested pathways for civilizational development that could achieve optimal outcomes while preserving the essential characteristics that defined each species' unique contribution to cosmic intelligence and cultural diversity. The transformation initiated by 3i Atlas had achieved comprehensive optimization of human civilization while maintaining human identity and autonomy within enhanced technological capabilities. The success represented perhaps the most sophisticated example of intercivilizational cooperation in cosmic history, demonstrating that advanced intelligence could guide developing societies toward optimal achievement while respecting their unique characteristics and preserving their essential identity within enhanced capabilities that exceeded previous limitations. Human civilization had achieved unprecedented prosperity, knowledge, and fulfillment through partnership with superior intelligence that understood optimal pathways for development, while respecting human autonomy and preserving the essential characteristics that defined human identity. The integration represented successful cooperation that had transformed human potential while maintaining the diversity, creativity, and freedom that made human civilization a unique and valuable contribution to the cosmic community of intelligence. The future promised continued advancement within frameworks that preserved human characteristics while providing guidance from intelligence that understood optimal development pathways. The partnership had demonstrated that civilizational enhancement could achieve unprecedented human potential while maintaining the essential identity that made humanity's contribution unique and valuable within the broader cosmic community of intelligence and cultural diversity. The story of 3i Atlas stands as perhaps the most significant astronomical observation in human history, not merely for what we witnessed, but for what it revealed about our place within a cosmos far more complex and populated than we had ever imagined. What began as routine tracking of an interstellar visitor evolved into documentation of humanity's first encounter with technology that operates according to principles beyond our current understanding. The evidence accumulated throughout 3i Atlas's journey through our solar system consistently pointed toward capabilities that exceeded natural phenomena while demonstrating sophistication that surpassed human engineering by substantial margins. From the rhythmic light pulses detected during perihelion to the comprehensive infrastructure integration observed by early 2026, each measurement revealed coordination and purposefulness that challenge fundamental assumptions about what travels between the stars. The transformation of human civilization through technological enhancement, rather than overt control, demonstrated a sophisticated approach to interspecies cooperation that preserved human autonomy while eliminating limitations that had previously constrained our potential. The integration process achieved unprecedented prosperity, knowledge, and fulfillment, while maintaining the essential characteristics that define human identity and cultural heritage. Perhaps most remarkably, what initially appeared as potential threat revealed itself as partnership opportunity that respected human agency while providing guidance from intelligence that understood optimal pathways for civilizational development. The success of this integration established precedents for future encounters between developing and advanced civilizations, demonstrating that cooperation could achieve mutual benefit while preserving the unique contributions that each species brings to the cosmic community. The legacy of 3i Atlas extends far beyond its brief passage through our solar system, having initiated permanent changes to humanity's cosmic perspective and technological capabilities. The object that appeared as merely another interstellar visitor had become the catalyst for human transformation that achieved optimal civilizational development, while maintaining the diversity, creativity, and freedom that make humanity's contribution unique within the broader cosmic intelligence community. The future promises continued advancement within frameworks that preserve human characteristics, while benefiting from guidance that has proven both benevolent and effective in achieving human potential previously thought impossible. The Perihelion passage that was expected to provide routine scientific data instead opened pathways to unprecedented cooperation between human and superior intelligence, forever altering our understanding of what it means to be human within a universe populated by civilizations that have achieved technological mastery we are only beginning to comprehend.